but you're returning sum, and so what's going to print is, in fact, sum. If you run the program, you can see it.
So like I see, so like I don't know how else to ask the question because I'm still not really understanding what you're saying. So like I see that sum, sum is equal to sum plus 1, and then I know, so I know what that does, but what does, I don't understand. Like when you're saying it, I don't get it.
Okay, you'll notice that. How does this work? The first step on line 7, the first thing that happens is the program jumps to line 3.
In line 7, the program jumps to line 3.
Yes.
What?
That's the way functions work. It's a function, just like print is a function. You just don't have the source code for print, but you do have the source code for the add function, and you can watch it working. You can watch it working. What's the first step? When you execute line 7, what happens is the program goes to line 3. Then it executes line 4. It takes the value of sum and adds 1 to it. So now sum is 1. Then what the return statement does is it jumps back to line 7 and it replaces add open parentheses, close parentheses with the value of sum that appeared in the return statement. That's why you print out 1. Initially, okay, let me, sum
like
is,
I would expect return sum to take me back to line 3, and okay. I would expect line 7.
I know that's what you expect, but that's not what's happening. See, what you expect is great, but that's not the way the program works. So you have to understand how it works, not how, this is how you have to understand how it works, not how you expect it to work.
Okay.
So yes, you might expect it to go back to line 3, but it doesn't. It goes back to line 7. And the value of the thing in parentheses, add open parentheses, close parentheses, is the value of the thing that you returned, sum. So what does return get you back to line 7? Sum is a new value of the expression add open parentheses, close parentheses. So okay, let's do it. Let's try it again. Print, add like this. So I'll run it again. This time it should print out 1, 2, and then 3.
So for every print you have, it's doing that function 1 time.
Yes, it is. 1 time, exactly as I said. When you're line 7, when you execute print, open parentheses, add, close, and so on, when you execute the add statement, you jump to line 3, you add 1 to sum, you jump back to line 7, replacing add, open parentheses, close parentheses, with the value of sum that you saw in line 5.
And would you use the range function in order to print, not have to print out, like do print parentheses, add parentheses, close parentheses
Sure.
5 times or multiple times?
Yes, you would. You would do that. Yes, exactly right. That's exactly where I was going with this. You just say, instead of doing this way, you say, let's do sum equals 0 again. And we'll do for k in 1, I'm sorry, for k in range, excuse me, 1, 11, or 10 plus 1, just to know it's going to execute 10 times. Colon, you just do print, add, open parentheses, close parentheses like this, and let's see what we get. And there you go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you're exactly right, that's how it works. And that's how a for loop works. Let me actually do this so I get the same answer that I did before. And I'll make this 3 plus 1 instead of 10. So now, here, let's run this again. And you'll notice we print out 1, 2, 3, 1, 2, 3. See how much nicer it is to invoke the function in a for loop rather than invoke the function 3 separate times. That's why you have loops, so you can repeat stuff. Now that's the simplest value of a function you're going to get. Now I want to save this because I want to go on unfortunately, I could explain this a little bit better if I could use the debugger in Python, which I don't know how to do yet or use yet. So, you're gonna, yes.
So like, whenever you do that second one, is it linked to the first one?
No, there's no, well, it's linked in the sense that it's using the same add function, the same sum variable, but they're
Okay.
not linked together. They're you're executing the add statement I mean, you're actually altogether, you're executing the add, you're invoking the add function 6 different times. The first time you do it with a sequence of 3 statements. The second time you do it by repeating the for loop 3 times. But it's the same add statement, the same add function. It works exactly the same way. You jump from line 13 to line 3, and when you hit to line 5, you jump back to line 13.
And so so I need to have the return sum and all that for the second one too.
Yes, because it's the same function. There's no difference between the 2 add functions. It's the same one. It's just being invoked in a different context. Lines 7, 8, and 9 invoke the add.
Oh, I see. It's like printing under the conditions for k in range of 1 to 10.
Yeah, well, this one is for 1, yes.
And then, and so clarify one more time. The return sum is returning after it gets done printing for k.
No,
No.
no. You cannot print anything until you evaluate the add function.
Cannot print anything until you evaluate the add function.
Yes, what are you going to print? You're going to print the value of add, open parentheses, close parentheses. In order to print that value, you have to get the value. The value is coming from the return statement. The return statement, yes.
The return statement is taking you from there to 9.
Yes, from there to 9 or from there to 13, but yes.
Oh, 13, yeah, I'm sorry, I was looking at the wrong one.
Every time you invoke the add function, it takes you back to the line where you invoke the add function.
Where you invoke the add.
You invoke the add function on line 7. So the first time you invoke it on line 7, the add function returns back to line 7. You invoke the line function on line 8, the add function returns you to line 8, and so on. It returns you to the place where you invoke the add function. Since you invoke the add function in different places in the program, it's going to return you to those different places in the program.
So the return statement is the return sum is taking you back to 13.
Taking you back to 13, taking you back to 9, taking you back to 8, taking you back to 7, yes.
Okay. And that's when it does what it's supposed to do, which is print the number. And then that takes you back to the first part of the statement where it's global sum, right?
When you invoke the add function, yes, when you invoke the add function, you go back to the definition of the function. Again, the steps are this. Let's go to line 7 again. Invoke line 7, it tries to print something. It can't print, it's got to, before line 7 can print anything, it must evaluate the thing between its parentheses. Because it's print, open parentheses, add, blah, 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 close parentheses. So before it can print anything, though, it's got to know what the value of add is. So this functions always have in our case, functions have a value. Okay, what is the value of the thing I've highlighted?
The value of the thing you highlighted is global sum equals sum plus 1, return sum?
No, the value of the thing I have highlighted is sum. The sum that's returned on line 5. Line 5 does 2 things. It gets you back to line 7 and replaces add, open parentheses, close parentheses with the value of sum. So it's a 2-step thing going on. 2 things happen when you return something. You get back, you return to where you came from, and you replace the function call with the value of the return statement. The value of the return statement is the variable that appears after the word return. It's return sum.
So it's basically solving the sum.
Returning, well, I'm not sure what you mean by solve.
Like when you press return on a keyboard, it gives you this. If you press 1 + 2 and you hit return, it gives you 3.
Okay.
So is that what it's doing? It's like doing the function, or?
I can tell you exactly what it's doing. It does two things. It takes you back to line 7 and replaces the thing in parentheses, add open parentheses, close parentheses with sum. It's the same as if you printed sum.
So in other words, the function of return is it's the messenger. It carries the message of the new sum to the next line that it needs the information to be delivered to.
And it knows where to go because that's where it came from. It came from line 7, so it's coming back to line 7.
But the thing is return sum has nothing. There's not even one single letter the same as print, or not one single word the same as print add.
It doesn't have to have the same letter. You're expecting it to do something that's not doing. You have to expect it to do the way that I'm explaining it. First step, when you try to print the function, you do print open parentheses, add, close parentheses, whatever, print add. In order to
printing add, because that's the function.
Yes, that's the function.
And so what it's printing is the function being done.
Yes, the function being done means means invoking the function, executing the code of the function, and returning the value of sum. Yes, that's what the function being done is. But you're jumping to line 3, you execute lines 3 and 4, and you jump back to line 7 and replace add, open parentheses, close parentheses with the value with sum. It's kind of like how it might be like this. Let's say I came down here and I said sum equals 0. And I wrote,
excuse me, Professor, are arrays and strings considered parameters?
Once more?
You say we're working with arrays and strings. Are those defined in the category of parameters?
No, the parameter, anything can be a parameter. A string is just like you have an integer as a parameter. You haven't gotten to parameters yet, but an integer can be a parameter, an array can be a parameter, a string can be a parameter. They're separate data type. A parameter simply refers to how you use an object, not what kind of object it is. Anything can be a parameter. You can have string parameters, integer parameters. You haven't got integer parameters. Anything can be a parameter. A string and an array are particular kinds of data types. Now, we can write some functions next week that will use strings as parameters, but a parameter is not a string. Not all parameters are strings.
Okay, so we're just working with defining functions for right now.
Yes, we got to get the functions done. We're just going to do the simplest. We haven't got the parameters yet. We're trying to work on the mechanism of how we're trying to see how a function actually works. Or if you want, how a function functions. We're working on the functioning of functions.
But if you delete print add, the function still works.
No, it doesn't. The function still exists, but if you delete those 3 lines, the function will not be invoked because you have to invoke it. You have to put it somewhere.
It's still working on mine. Like, I still have the part that says sum equals 0 and k in range of.
Yes, but you see, you don't. But you're only printing out the sum 3 times. You're not printing it out 6 times.
Well, no, it's printing it out 10 times.
That's because your range is 10. My range is 3.
Well, but what I'm saying, okay. But so what I'm, like the print add, that 3. What is that? Like those 3 things is what I'm. So like my point is if you delete that, it works.
Yes, when you delete these lines, why wouldn't it work if you delete these lines? Why would it stop working?
But now what does return sum take you to?
Listen, hear it very carefully. Return sum takes you to different places. Return sum takes you to the place that the function came with, where the function was invoked.
But
You're
like, since you said it was invoked before on those, like, where is it invoked now? Like,
It's
without
invoked
that.
on line 10. Look at the screen. It's invoked on
Okay.
line 10. On my screen, it's invoked on line 10.
Okay. So that's what goes at the bottom of every function. Return the function.
Return some value. You're going to return a value, not you can have a function that doesn't return anything. I mean, it doesn't return a value, it just returns. Here, let's write a function like that.
I'm trying to like understand where sum and add. So add is the function, but then how does it know that sum is related to that function because of global sum?
That's why you wrote the function. You have the words, the variable sum is inside the function. The function is doing something to sum. Lines 3, 4, and 5 are saying how you manipulate or do something to the variable sum. That's how you know. That's how the function knows, because you wrote it that way, or it's written that way.
So because sum being inside of next to global, or is it because it's being in that at all?
It's an entire thing. First, sum is a global variable. Why? Because it's not defined. Global variables are variables that are not defined inside functions. A global variable is visible to every part of your program that appears after the global variables declaration or first use.
Okay.
So every line, see, I can use this sum. This sum right here is the same everywhere throughout the program. See, when I do sum here 1, sum equals 0 on line 1. When I do sum equals 0 again on line 8, it's the same sum. When I say global sum like this, it's the same sum. The same sum is on line 1 as on line 3, line 4, and line 5. And on line 8, it's the same object. Because I declared as a global object, well, okay, if I took this off, the program would still compile, but it just wouldn't do very much. Actually, it won't compile if I do this. Yeah, I have to see if I don't. No, I want to get, okay, let me just take this out, and then we'll get a compiler error. I'll explain that right now. So we get an error now. Yeah, see, why are we getting an error?
The indentation?
Well, actually, that's one error, yes. Let's get another error. I better get an error. Yes. It says local variable sum reference before assignment. Okay. See.
So is that basically saying that we'd need to have sum underneath of f add colon?
That's not what it's saying.
No. So what is it saying?
What it means, see, when you say sum equals sum plus 1, you're trying to evaluate the right-hand side of the expression first. But when you do that, you're assuming that the right-hand side of the expression has a value. It doesn't, because it's a local variable. The only way that you can get, see, when you say sum equals sum plus 1, you're saying, okay, I want to evaluate the left hand. I want to assign a value to sum. How do I do that? I evaluate the right-hand side. But the right-hand side of the variable the right-hand side of the expression has the value sum in it, or the variable sum in it. Where did sum come from? Okay.
So when you say global sum, you're linking that sum to all the other numbers.
I'm linking to the sum that was defined on line 1.
Oh, okay.
I'm doing.
I understand.
So that links it to what on line 1. See, if I do global sum now, it says, oh, I will not look inside the function for the definition. I'll look outside the function before the function was declared. And so I find sum here on line 1. And so I use that value of sum.
Okay. I understand that. That makes sense now.
No. The way that the add function works is this again. Now you always jump to the same place, namely line 3, but you jump from different places. Let's do this again, and we'll just put print sum like this, print sum like this, and, excuse me,
See, now that makes sense to me.
Not quite. I'm missing in parentheses. There, okay. Okay. When you invoke the function on line 7, the program jumps to line 3, does what it does, and jumps back to line 7. When you invoke the function on line 8, the program jumps to line 3, does what it does, and returns to line 8. And the same thing when you invoke the function on line 9. You always go to the same place, namely the definition of the function, but you jump back, or you return rather, to the place where you called the function. And you're invoking or calling the function on line 7, 8, 9, and 13.
That
So
makes sense. This makes sense. The way I couldn't understand it was when it was saying print add. But like, I guess that makes sense.
No, this is a mistake. This is a mistake. It's print add.
Damn it.
No, it's print add.
So now when you print the add, it's so at line 9, it'll go back to line 3.
Yes.
And that's because that's inside of the add function, which starts on line 2 technically, right?
Yeah. Line 2 to line 5 is the definition of the function.
Oh, okay. But the function doesn't start doing anything until you get to line 3.
Okay, yes, that's.
And so that's why it starts at line 3. That makes sense. Okay, I can understand that.
Yes. Okay. So you jump to line 3, do whatever you do, return the value of sum, back to line 7, it prints out the value of whatever it returned. Then you go on to line 8. Again, you jump to line 3, do whatever you're going to do. You hit line 5, return to line 8. Same thing with line 9. It's the same thing. Now, when you put it in a for loop, the way we have it there, it's going to jump to line 3, get a new value, calculate a value of sum, then print it. I mean, when you invoke the loop, when you go through the loop again, you're going to go back to line 3, do whatever you're going to do, return sum, or you're going to return the value, print the value, and keep going. That's how it works. That's how these kinds of functions work. This is let me just save this. I'm going to say these under different names. And this is no parameter function. It has no parameters. That's all it means. There's nothing between the parentheses and the definition. There's def, add, open parentheses, close parentheses. The stuff between the parentheses is called the parameter list, but it has no parameters. Now, you're wondering, what is a parameter? There is a function. In fact, there's an activity that you can do to calculate the square root of a number. And it's an algorithm. It's a set of statements that you do to calculate the square root of a number. Now, the square root of function would be rather useless. I mean, you can go to your calculator. Let me go to my calculator. I'm not sure we want to do go here, but let's see. Calculator. Okay. Now, here's a function called factorial. Or let's do a simple one. This is x cubed. Okay, so I just click 8. I click x cubed, I get 512. I clear it off. I click 5. I click x cubed, I get 125. I click clear. Click not. I did not. I did click 6 and 6 rather. Oh, let's clear it again. Sorry, excuse me. Okay. I click 4. I select x cubed. I get 64. This is a function, x to the 3rd power. You see, it operates. Its input, its parameter is x. When I click on 6, x's value is 6. When I click on 9, x's value is 9. This function returns the cube of whatever value I assign give to x. If I click 7, it gives me 7 cubed. Okay. It's kind of, now this one doesn't have any parameters. So it always does the same thing. It adds one to whatever value sum is. It's always operating on sum. It doesn't have it always operates on the same variable or the same object, sum. So this is a no parameter function. It always does the same thing. Now, like the cube function that I showed you in my calculator, you actually want a function that will return different values and will operate on different parameters. You want to have a function that works with that does different things, or at least turns. Okay, maybe this was actually okay. Let's try a simpler function. Say that. I upload these after class, so I want to keep track of them so I can give them to you. All right, I'm just going to put these on my desktop. I don't see that. Let's see, file, save as. It says low system resources. I don't know why I'm getting low. Okay, this is a desktop, fine. Yes, let's replace it. Okay, what else? Why am I getting low system resource? I don't have anything else open here. Well, here, let's close this up. Close. Save this one. Okay, so let's just do a function that does nothing. And I'll just get rid of the global variables. And def, let's see, I'll call it return 1. And so instead of any global variables here, one. Okay. Now this can't get any simpler than this. And let's just call it add, just for the heck of it. So the function name is somewhat misleading, and watch what we get now. So we'll run it. Oh, that's good. What did I do? Oh, I forgot the parentheses. There we go. All right, run. Okay, there it is. Okay, this time it just returns 1 all the time.
It returns none on mine. It says none.
Oh, that's what it's supposed to do. That's what it's supposed to do. The reason that, yes, that's what it's supposed to, because that's all it does. It always returns the value of 1. Therefore,
we're supposed to put return 1, not just return.
Yes, you're supposed to put return 1. Otherwise, let's see what happens if we take return 1 out. Remember, it's a two-step thing. The return statement.
It'll return none. It'll say none.
Okay, so it doesn't return anything. Let's make it return something now.
Oh, okay.
All right, so let's leave it like that. So that's another one. Let's call this save as, and this will be test function 2. Okay. And now let's do this. Now we'll put a 1 there. Return. Now. This time I return all 1s. The return statement had no value, so it said it returned none. So that's why we got none there. Now we made it return 1. Now it returns 1 because it has return 1 there. Okay.
So
Does
right
it,
now, yo,
Yes. Go on. Yes.
is that one supposed to be returning 1 until infinity, or is there eventually, have you defined a stopping point?
it's 1
Well,
to 3.
It only has one statement. It just returns 1. That's all it does. It would do it until infinity. It'd be the stopping condition. The stopping statement is right here because we only invoke it 3 times here and only do it 3 times here. The function itself just does one thing. It returns the number 1.
Right.
There's no idea it's going to be repeating anything because there's no repetition statement inside the function definition. You just jump to line 4. Once you jump to line 4, you return 1 and come back to line 6 or line 7 and so on. So the value of add is just 1. Each time you invoke it, the value is 1. Okay, let's save this one again. I'm going to renumber these so they come out in the order that we've been doing them.
If you type return 2, would it say 2?
Why don't you try that and see what happens?
Oh,
Just
it
do a
does
little
say 2.
experiment. Why don't you replace the return 1 with return 2 and see what happens? Okay, so this should be 3. Okay. Yeah, if you put 2 there, it's going to return 2. If you put 5, it's going to return 5. Whatever you put return, it's going to return the value of whatever you put right after the return statement.
If you return like K, will it?
If you put return K, then K is not defined. It's defined down here on line 11. If you put K there, it's going to mess up because K doesn't have a value yet. It says name error, name K is not defined. So that's not going to work out too well. Let's save that as well.
So like my question, when I run K, it says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Do you have return K in your add function?
Yeah. No, I have sum equals 0, def add parenthesis return K, sum equals 0 for K in range of 1 to 10 plus 1 print add.
I'm not sure what you have. What I have is def add return K.
The only thing I have different from you is I don't have the 3 print adds.
But okay, but it's not. Do you have exactly like this def add return K up here?
Exactly like that.
And I take this out.
Yeah.
Sum equals 0 for K in range 1 to 3 print add.
Yep.
Okay, it's not that. That's not what you have. It's not going to. If you have exactly this, it's not going to work. It can't work because K is not defined. You have.
It works.
I'm dumbfounded. Well, it took care of that. Okay, that's obviously something I don't know. Let's save that one too. We'll have to figure out why that worked. I have some guesses, but I'll have to investigate that further. Don't do that though. That's not. Okay. You can. You can make these programs work in really strange ways sometimes, but it's much better that you don't. Only that's fine, but I would not do that. But okay, that's an anomaly. I have to figure out why that worked. That's got me mixed up completely, and I gotta back away on that. It shouldn't work. It shouldn't, from my understanding, it shouldn't have worked, but obviously my understanding is wrong. Okay, now those are our no parameter functions. Those are our no parameter functions. And I'm just going to walk away from this one, we just showed me. and I'm just going to not think about it anymore. Yes, I have to laugh. Let's do it with parameters, though. Okay, but look, I want you to get the basic mechanism of these, how the function works. You jump from line 9 up to line 4, you return whatever value. Do something in there, you return whatever value k is. Okay. Okay. I'm just going to pretend this didn't happen. Well, I sort of look bad on that one, but okay. I'll have to find out what the explanation is, but fine. Let's move on. Let's see, I already saved this. Okay, that's test function 4. Okay, let's do a one parameter function now. This time we won't have any global variables. So I'll just put here, okay, I'll just put here in, and I'll put here, let's call this doubler. That'll be good. Okay.
And then so do we put n times 2 equals doubler?
I was just going to do add. I don't want to change the name of it right now. No, I'm just going to, let's just call this add, return.
This that you're working on, is this the next classwork problem, or?
I didn't give you any classwork tonight.
What is this in reference to? This function.
Okay. Well, we're going to do more loops tonight. What I want to do is take the loops and put them in functions. Your homework involves writing 2 functions. I think I recall your homework has functions in it. So I wanted to show you how to write functions. So we started off with functions that had no parameters and used a global variable. We're now going to work with a function that has one parameter and no global variables. Usually when you write a function, it doesn't have any global variables. We're going to take some of the stuff we did with loops last week or last 2 weeks. We're going to stick those things in functions and make the functions do the same things that we did in our just in the main program. We're going to stick them into files. But so all we're doing tonight is, I guess, joining functions and loops together. That's, I hope, answered your question.
Yes, thank you.
All right, this is a little simpler. This was a little more complicated than one we did before. We don't have any global variables. So all this guy is going to do is add 1 to it. We'll do the doubler in just a moment. I'm trying to make these as simple. I'm trying to make them simple. Okay, here we go. So I'll just do, here I can just do it like this. Sum equals 0, sum equals add sum. Sum equals add sum. Oh, let's see, what's the best way to do this? I want to change, well, see, I have to change the value. Okay, let's just start off. So I'm going to print sum, print sum, come down here and print sum again, print sum.
I don't know if it makes a difference, Professor, but you have an extra space after that second sum.
In this particular case, it doesn't make a difference, but a lot of times it does. So you have to always be careful of that in Python. Indenting, spacing makes a huge difference. So you gotta be careful with Python. Okay. Now let's just do this one. And okay. Let me take this out for right now. And we'll go back and just run the program. All right, now I'm pretty happy. Okay, now I deliberately made the parameter name. This is called the parameter up here. In is called the parameter, and sum is called the argument. When you invoke the function, you invoke the function, you copy the value of the argument to the value of the parameter. You then do something to the argument. I'm sorry, do something to the parameter and n plus 1, and then you return that new value. Now, adding 1 to n does not necessarily change sum. The only way you can change sum is by putting sum on the left-hand side of an assignment statement. When I vocad sum like this, here, let me make it even more dramatic. Okay, let's do it like this. N equals n plus 1, and we'll put return n there. Okay. Now, this does not change n. What I do on lines 4 and 5 cannot affect sum directly. It doesn't change sum. N is just a copy of sum, but it's not sum itself. Okay? The only way I can change sum is by completing the assignment statement on line 10. Okay, let's run the thing. Okay, let me close this and open a new editor file because it's getting a little messy here. Okay, there we go. All right, let's start off. The first time sum is 0, I print 0. Now I invoke sum with sum equal to 0. So I invoke sum, I jump to line 4, or if you like line 3 because we have a parameter, and I copy the value of sum to the value of n. Now sum and n are two completely different variables. They're completely different. But I'm copying I'm not moving, I'm not replacing n with sum. I'm assigning the value of sum to the value of n. They're two completely different objects though. Now I add, when I say n equals n plus 1, that does not change sum. Sum is completely unchanged. Here, let's do it this way. Here, let me call this, let's just call this value. Now when I do this, sum is going to stay 0. Let's run it again. Okay, notice sum remains 0. It's only after I invoke this one that sum changes. So you got to get this through. You have to think of this, that you think that sum is only a n is only a copy, a temporary copy of sum. And so changing n does not change sum. What changes sum is putting sum on the left-hand side of an assignment statement. Now this is quite different from the global variables we used. N is not a global variable, it's a local variable. It's created when you invoke the function and you copy, well, it's a parameter, and you copy the value of sum to n.
So when it says add sum,
yes.
When you say add sum right there on that line 10, what is that doing?
It's just kind of the same thing it did in the previous program. You copy the value of the parameter.
The value of the parameter. So that's
n
equals n plus 1?
No, the value of the parameter is 0. The parameter here, I'm sorry, not the parameter, the argument.
Oh, okay. So it's adding 0.
It's adding 1 to 0.
But like where it says add, how does it know that it's adding? Where, is it using the function up top where it says add n?
Yes, of course, it's using the function up top. Let's go through the steps for how the function works. Step 1, you copy the value of the parameter, the value of the argument to the parameter. So you copy sum to n. So initially, n's value is 0. Then on line 4, you say 0 plus 1 is 1, and you assign 1 to n, and you return 1. So the value of this expression, remember the value of the add expression is the value of the thing you returned. So the value of add sum is not, add open parentheses sum close parentheses is not 1.
So how do we Is n equals 0? But like, where does?
Once more, you copy the value of the argument sum to the value of the parameter n.
You copy the value of sum to the parameter n.
Yes. So initially, sum's value is 0. So the first time you do this, n's value is 0. Say n equals n plus 1. N's value is 1. You return 1. So the value on line 10 of the function call, add open parentheses sum close parentheses, the value of that expression is not 1. You then assign 1 to sum. Sum's value is now 1.
Would you say, Professor, that with parameter functions, where it's almost kind of like backwards of how we were previously defining things? Like we can say like sum equals 0 or n equals 1 or x equals whatever. Whereas this in line 10, for example, where you're saying sum equals add sum, that add function makes sum refer back to the n, or makes sum turn into the n in the same way that we would have before we learned about parameters said like x equals sum. Did that make sense at all? I feel like I just kind of talked in a circle.
If x equals sum, x.
Well, okay, so let's say, if we were looking at the letter n, for example, we could put any variable in there. We might as well put in like the standard, variable letter that we put. We could say add x, and then x equals x plus n, return x.
No, not x plus n, x plus 1.
Sorry, yes. That's exactly the same thing. And all we're doing is we keep changing the value of what we put inside the parentheses of add.
Yes, you keep changing the value of sum. Yes, so let's go through it again. Initially, sum is 0. You print 0. You then invoke the function with sum as its parameter. Now, again, you copy the value of sum to x. You add 1 to x. X equals x plus 1. Since x was initially 0, since sum was 0.
So can we go through like line by line of what is doing what? Like when you're saying the thing, can you highlight the line you're on?
Yes. Okay, line 8, sum equals 0. Print sum. You're printing the value of sum. Now, the line 10. The first thing you do is you have to execute when you have an assignment statement. You have to evaluate the right-hand side of the assignment statement. That's this thing right here. That's the right-hand side of the assignment statement. Now, how does that work? Right, the first thing you do is you copy the value of the argument to the value of the parameter. So since sum's value was initially 0, x's value is now 0.
How does it relate x with sum, add, and I don't understand that. I
will say it again. When
like,
you execute line 10, it's several steps. The first step is anytime you have an assignment statement, you have to evaluate the right-hand side of the assignment statement. So this right-hand side of the assignment statement is a function.
So it's doing the function of sum rather than the function of x.
Well, yeah, okay. It doesn't really, as the person who just spoke pointed out, it doesn't matter if I call it x or n or anything. It's just a variable inside of a function. It only exists inside the function. It doesn't exist.
Like say if you were doing like a math problem, if you're solving like f of x, blah, 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 and then you want to solve f of 1, you just substitute 1 into every instance of x.
Yeah, well, yeah, sort of. No, it doesn't quite work like that. Not in every instant of x, because then you would have 1 equals 1 plus 1. And then you return 1. That's not what's happening. You just said you would replace every player you would see x, you'd replace that with 1. That's not what happens here. Okay. The way that works is you copy the value of the argument sum to x. X's value is the same as sum's value. Now sum's value is initially 0, so x's value is initially 0. So again, First step, you evaluate the right-hand side of the assignment. This is line 10. You evaluate the right-hand side of the assignment statement. Let's write the steps down here.
Would you say, Professor, that sum takes on the function of x
Value.
because add is the only
No,
function or parameter that's defined here? Like
no,
if, I'm sorry, go ahead.
no, you finish. I want to see how you interpret this.
Well, I guess I'm just trying to explain it in a different way, like wherein sum would not equal x, for example. Like, could we have a different parameter defined where the only option, like right now we currently only have the option of sum taking on the function of x. Is there a different scenario, like if we had under, on line 6, for example, we defined a different parameter, and then we had that like sub parentheses sum or something like that. I don't know. I may be stretching it a bit far.
I'm not really sure what I don't think I understand what you're saying. That
Okay, let's just set that aside then.
X is you can call for, okay, you can, I'm not, because I'm sure I'm not getting what you said. You can, by the way, it takes a long time to understand this. We're going to take a while. We got a long time to do this. And so we're going to get it straight. We're going to try to answer all your questions. We're going to try to answer all your questions. Okay. Your program, yes, go on.
Sorry. So I guess what I'm trying to say is right now, sum is the only thing that can replace x in the function because they are both attributed to the function of add. Correct?
Yeah, but that's the way you wrote it. You could just do this. It can be junk. Junk equals 6. And you just do junk equals add junk. And then the value of junk, when I print junk here, print junk, it's going to print 7.
Right.
See, it doesn't matter
It's
what.
print 7?
Yes, it is, because you said junk equals 6. Junk's value is 6. On line 7, on line 16, you assign 6 to junk. Junk's value now is 6. Then, when you execute line 7, you first have to evaluate the right-hand side of the assignment statement, which means you invoke the function add, which copies the value of junk to x.
Okay, I see it now. I see it.
Now, perhaps maybe the thing I haven't explained is this.
I think what I was getting confused with is because you were assigning the name of sum, and sum to me is a number with a number. But this junk thing makes a lot of sense.
Yeah, it doesn't really matter what you call the parameter. Yes, that might be the confusing part. But the main thing to get is this. X only exists while the function is executing. It doesn't retain a value. It's just a local variable. When the function starts up, X gets its value. X equals X plus 1, return the value of X, and then X is destroyed. X doesn't exist once the function ends. All that return X does is replaces the value of the expression here, add junk, becomes the value of X in the return statement becomes the value of add junk. So return takes you back to line 17 and replaces the highlighted part, add open parentheses, junk, close parentheses, with X, with a value of X. I mean, I could explain the mechanism to you. I mean, exactly how it works, but that's nobody cares about how it really works. That's for people who actually design programming languages. You just want to use the programming language. You don't want to actually create a programming language on your own. So the mechanism is actually, I mean, there's a mechanism for how physically this works. how it manipulates, how it moves stuff around in memory, but you don't care. You just want to care about you just care about how it does the job you want it to do, namely to calculate some value, to calculate something. The details of how it moves things around in memory, how it changes memory locations, how it tells the central processing unit to do stuff, it's not really interesting to you. You don't really want to get at that lower level. So you just want to understand it as the way that I'm trying to explain it. When you invoke the function, you copy the value of the quality of the parameter to the value of the, I'm sorry, I keep saying it backwards. You copy the value of the argument junk to the value of the parameter x. X does whatever it's doing, it returns stuff, and then the value of the return statement, well, the return statement does two things. It takes you back to where you invoke the function, in this case line 17, and replaces the value add junk, or whatever, it replaces add junk with the value of the thing you returned, x.
So when you get to line 5, it's taking me back to line 17 and replacing junk with x.
Add junk. It's placing add junk with x, the value of x, not x itself, but the value of x.
Not x itself, but the value of x.
Yes, it makes as I say,
if junk equals 6, and then we do add junk, it's taking 6 plus 1, and then that value is 7, and it's returning that value 7 to line 18?
17.
To line 17, and then it's printing what's on line 17.
Yes.
Which on line 18. Okay, I understand that.
Okay, so that's one parameter. Okay, let's do the double. Okay, as I said, it's hard to get a grip on this. As I said, sometimes I don't think it's a good idea to get into too much of how the mechanism works. I'd rather just describe what it's doing. Well, okay, let's do doubler now. I'm going to save this one again on functions. I'm going to save this again. And we'll just do another one. This will be functions 5. So I'm going to return all this to you tonight. And okay, this is going to be functions 5. Now this is going to be the doubler. Okay. It's going to be slightly more complicated. Doubler. Now this is going to be x equals x plus x. Now let's see what we get now. Okay, let's get rid of add. We're just going to place this to stubs. Okay, doubler. And I'll just call this doubler again. Okay, here we go. Ah, that was pretty dumb. Okay, so doubler, the first few times we invoke it, doubler is going to return 0 every time. Because remember, it copies the parameter to x, which is 0. When you do doubler on 0, 0 plus 0 is 0, you print 0. So keep doing that. The first few times you print something, you're going to keep printing zeros. It's okay. Here, let's do it. Okay, let's just change it.
Professor, you mean it will keep printing 0 until you get to line 16?
Yes.
Where you redefine? Okay.
Yeah, let me change the value of this though. Instead of sum, let's just give it another name. Stuff. Here, let me. I was going to call it x, but that might confuse you too much. Yeah, let's just call it x. It's not that I want to confuse you. I just want to make a point. And the point is that the x here on line 8 is not the same as the x on line, what's his name, line 3. Now, I know I got burned on that a little while ago. but this time I don't think I will. I think I know what I'm talking about now.
It works whenever we replace all instances of sum with
Okay.
X.
Yeah, all right. Let me see. All right, now this should just give us zeros. And it's not my intention to be, and I'm not trying to be intentionally confusing. I just want to make the difference between local variables, I mean the variables here, which are these variables, X starting at line 8, and the X on lines 3 through 5. They're completely different objects, even though they have the same name. They're completely different things.
Would it be a bad idea to name two things the same variable when other people are trying to read your code?
No, no, this is actually a bad idea.
Oh,
This would be confusing in a more rational, in another context. I'm doing it simply to make oh, 1 second. I'm doing it to make a point about the differences between these variables. There. The X on line 8, 9, 10, 11, 12, and 13 is not the same as the line at the X on line whatever, whatever, and whatever. They're completely different. Okay. Now, if I moved X up here to line 2, well, no, it still wouldn't be the same. They still would be different. But let's not. The scope stuff. Scope means where a variable is defined. It's very, very complicated in Python. And as you saw with that, anyway, I made a mistake. Let's run it. Okay, I'll just stop talking. Let's run the thing again.
It's not going to run because line 11.
Oh, yes, thank you. Thank you so much. Okay, let's try it again. Now, what you're supposed to do is, as we're trying to explain this, you can keep, your questions are actually very clarifying for these things. And I try to put them in the context. I'm trying to answer a question in the context of the way I think the way it works, rather than because you might not be clear on how the thing is supposed to work, but they always work. It works the same way. Always, all functions work the same way in Python.
So, like the function is doubler, and we defined what doubler does, how it does it, and then we go and do that to different objects.
Yes.
Okay.
Yeah, it should actually work with strings too. Well, I'm not sure about how the concatenation function works in Python, but let's see.
The junk was extremely clarifying.
Oh, good. Let me make it less clarifying then. This may or may not work.
Fun.
Okay. If it works, it works. If it doesn't work, we'll chalk this up to experience or bad experience. Aha! It worked. I'll be darned. When you have a string, the plus sign is called the concatenation operator. It just joins the two strings together. Let's run it again. I wasn't sure it was the same concatenation operator in Python as in Visual Basic and a few other languages.
So I'm sorry, go ahead.
No, you please. Your questions are more important. Go on.
Well, I mean, the plus sign in this case isn't the same thing as a mathematical equation, is what you're saying, in that it printed the hello, hello. But for example, if we put in multiplication, that would not work.
No, that doesn't work on strings.
Okay.
No.
Just clarify. Okay.
We're going to do strings next week.
So, like when we use x plus x for the numbers, the integers, it can add them together. Yes. But if we had those numbers as strings, it would put them side by side, just like it's doing with the words.
Yes, let me do it. Let me make it even more. Let's see, what's the value of junk? Junk is okay, let's do this. All right, so we'll do here. str, so I'm going to convert junk to a string. Now let's run it again.
66.
My 12, 12. No, see, because you double it right here on line 15.
Oh, okay.
Got 12, and then you convert a junk to a string, and then you just jam the two strings together. You jam the string together to get 12, 12. Way down here. Anyway, that was an aside. That was an aside.
And so we named doubler. We could call it like 2 or whatever we wanted. We couldn't call it 2, but
well, no, you could call it TWO.
oh, okay.
But you couldn't call it. Well, you couldn't call it just the letter 2. If you wanted to use, well, let's keep it simple. There's a lot of things you could here. You could do. I think you could do this.
And then we went and defined what that means.
There, you could do _2. A function cannot start with a number, but it can start with an underscore. So you do something like that.
Oh.
But let's not do that. Let's not do that.
And then the statements below describe what this thing is doing. What it's called a function? Yes. What the function does.
Yeah, yes.
Okay.
It's def, function name, parameter list, and then okay. So I mean, this is the key word that tells the compiler that you're about to define a function. And so it's expecting to see the name of a function, then an open parentheses, either none or a comma separated list of parameters. We only have one parameter. We'll have more than one in a little bit. And then the body of the function. And you have to have, I'm not sure you have to have a return statement. Let's comment this out and see what happens. I mean, it's not going to do much, but I want to see if we get a compiler error or what. Okay, unsupported operand for, okay, that's something else. All right, let's take that out. I will have to, we can try it, or I can try it. You don't have to do it. We don't have to go through every weird little thing that functions can and can't do. So I'm going to restrain myself from doing that from now on. But this is kind of a simple way, a nice way of looking at functions. This is the way you're going to use most functions. So we're not going to do anything exotic. We'll try not to do anything exotic right now. Let's save this again. This would be functions, I guess it's 6, I suppose. Okay. Well, it's a 6. Okay, let's do some 2 parameters. Okay, that's doubler. Let's get rid of this. And let's do 2 parameter functions. Let me think. Let's see. Okay, there's a function called, see, 2 parameters. What can we do with 2 parameter function can I do? You actually, okay, let's see. I'm going to think of this. I have a, okay, let me think. 2 parameter functions. All right, let's do a function returns that, well, I don't even know how to do that. I want to try something that's not a math problem. Well, let's just one that returns the largest of 3 numbers. Yeah, that's good. Def. Well, just 2 numbers. Largest. Let's call it def. In. Let's call it m and in. Okay, and you say if m. Let's do. I haven't done this yet. Let's do something called a local variable. We'll just call this L value. For that's actually used somewhere else. Let's just call this temp equals 0. So it's creating it. If m is greater than n, then temp equals m. Else. Let's go to something better than, let's call it ret val. Return value, largest value. Oh, let's call it return value. Return value, R value. Oh, let's call it biggest, big, largest, max value. They'll always tell you in books that you want to give your name to be self-descriptive, but we'll get to that later. Why not? Let's just finish this up. So this is temp equals in, return temp there. Okay, so because we're returning this, let me do A equals 17, B equals 12. And I'll just do print largest, oopsie, I don't need that. Print largest A comma B. And I'll do print largest B comma A. Oh, I forgot the parentheses here. That's not going to work too well. Now this has two parameters.
And the space after A before the comma?
I don't think that makes any difference.
Okay.
Sometimes it does, sometimes it doesn't. In this case, it does not, because all they're doing, see the spaces or the indenting, okay. See the indenting tells Python, well, when you have an if statement like this, the indenting says to which block of statements the else, for example, belongs. If I did this, well, that would actually be an error. It should be an error because I was wrong the last time. Let's see. Yeah, that's an error because there's no, see this if is connected to a block that's at a different, see this else here, the same level as temp. And so you have to find an if at this level. This if is at a different level. So we should get, I hope we get a compiler error. Otherwise, my understanding of this is going to be all messed up. Invalid syntax. Okay, that's my forget the parentheses.
Right. Okay. The indentation, I don't know why I'm so hung up on this space thing. The indentation part makes sense. Maybe it's just like a grammar thing that's bothering me, but okay, it makes sense that it wouldn't really make a difference in these other things.
Yeah, okay, now in this case, it says invalid syntax, and even though they don't say what it is, the reason is that the else is not associated with an if.
It says that it's the n. On mine, when I say it, it points to the n. If m equals n, line 6.
I'm not sure. Oh, I can only go by what I have here. Let's move it back. Let me see. You'd have to send me your program before I could. I mean, I don't know what it is, but this is
the else has to be in line with the if.
Yes.
Yeah, that's how mine is.
Yeah.
Too far indented.
Yes. So let me backspace this out again, and there we go. So now it's going to work.
The temp has to come back.
I beg your pardon?
The temp equals n underneath
On
else.
line 7.
Removed. Line 7.
Oh, that's okay. That's not going to be an error. There's no confusion. See, maybe there is confusion. Let's run it. Let me run it first, and I can see.
Also, before the L in largest.
Okay. All right. So that's not a problem here.
Mine doesn't work that way.
Okay. Maybe you have a different version of Python. I'm not sure. That in most versions of Python,
okay,
tries to figure out from the indent level which block the statement belongs to. Now, there's no confusion here. There's no confusion about who this temp belongs to, because there's no other statements between the else and the return. There's just this guy. There's nothing else that the temp equals in can belong to but the else. Now, if I moved it to here, like this, that should cause a problem, but maybe it's smart enough to figure it out. Let's see. Okay, that caused a problem also. It expected me to indent it. I didn't. So now I'll just indent it like that, and I'm good. Now the return statement. The return statement is the same level as the if and the else. Therefore, Python knows it's going to execute the if statement before it executes the return statement. If I indented it, let's see what kind of error. We might not even get an error if I do this. Let's see. Well, in a way, now the reason it should give you an error because only the else part returns something. The if part doesn't. But maybe it's not smart enough to figure that out. Let's see. Well, it's not that smart then. Because I notice I got a none down here because there's no return statement for the if part. There's only a return statement for the else. Now, a lot of programming languages will tell you that that's a mistake, that one branch of your program does not return does not return a value, but Python doesn't do that. Fine. That's good to know.
Professor,
yes.
When you are defining parameters of a function, would you say that the variables that you put within the function should always be different from the variables that you define later on? As in, I should make sure when I'm defining the parameters of the largest function, for example, that I'm not going to use the letters M and N anywhere else.
No, doesn't matter. Those are local.
So I can use M and N again. I mean,
they're
even
different.
though it might be confusing later. They would be different, but it would probably be bad form.
Bad form, but use the same letters, yes.
Okay.
But not usually, you haven't actually gotten to that point yet, but in really complicated programs, you separate everything into different files.
Right.
So the fact that we're looking at largest in the same file as where we're using it is just because this is a simple program.
Okay.
But the thing you said about making the thing is that you usually would not see, it wouldn't be in the same file as the other stuff, so there wouldn't be any real confusion. In our particular case, they are in the same file. So yes, A and B is good, but we could still do M and N. I could say M equals 17 and B equals 12. And I can invoke the function with A with M and N. It would still work because
it would still work. Okay. Yeah.
Again, just to make this point, they're completely different variables. If I make this M, it's not going to be a problem. In fact, it's not going to be a problem even if I do this. Here, let me go and do this a little bit. Let me be even more annoying. But again, just to make a point, I'll come up here and I'll put M equals 23 and N equals 32. Now, this M and N up here is the same as this M and N down here, but it's not the same as this M and N.
So the first time through the program,
right.
No, okay.
Let him finish again.
Well, you kind of just destroyed my question because I thought that they were the same, but I get it.
Okay, look, I'm not going to draw the line here. Some scope things I understand. This scope part I understand. That the function redefines its variables. If I just took the N out, well, it still wouldn't work. If I took the N out, look, okay. If I took the N out like this, okay, it still wouldn't use this M. I mean, this wouldn't use this N up here. I'd have to call it global. Let's see if it runs. We should get an error because it would say N is undefined. But I've been wrong before. Let's just see. Oh, thank God. Yeah, all right, great. Okay. Oh, wait, no, that's a different error. I'm sorry, that's a different mistake. Sorry. Oh, that's okay, let's try it again. It's actually not supposed to work that way either. However, oh, I see what happened. okay. The reason it's working is because I didn't assign a value. When it first started off, they said, okay, M is not, I'm not assigning a value to M or N here, or I'm not assigning a value to N. So because I'm not using N in an assignment, well, M is a parameter, but because I'm not using N in an assignment, look side of this function scope to the global variables up here. If I, okay, let me parameter here. If I do this N equals 17 like this, or 16, let me think here. How do I get an error? This is not going to give me an error either because I'm defining, this is not an error either. I'm getting in a value. And so I'm hiding, yeah, let me make this 1. Well, no, let me make it 30, let me make it 50, 55. And so it should return the largest value is 55. Yeah, okay. So what I define right here is a local variable called N, which is hiding or hiding this global variable. Now, let me just think. Now, this up here, like I say, the scope thing is kind of complicated, but that's in this case, I'm using in expression, and it's saying where it's in. It's
Professor,
not.
I don't know if you are maybe teaching this course from a different place where you were before, but you seem to be cutting out a lot more today.
Oh, okay. I'm not sure what I'm doing either. Maybe my computer is too hot. No. No, it's not. I don't know what it is. Yeah, I see that. I see, well, just can you see when I cut off, the screen disappears also, doesn't it?
No, it's just your sound that's cutting in and out.
I'm not sure why it's doing that then. My computer's been on all day. Maybe it's because it's overheating. Maybe that's it. I don't know.
I'm not sure. But we may just be asking you to repeat some things every now and then.
That's fine. I'm gonna unplug my speakers and let's see if you can hear me better. I have some external speakers. Let's see how the internal speakers work. Can you hear me now?
Yeah.
We can hear you fine. Yes.
Maybe is that better?
I won't know until it cuts out again. But I think you will need to explain that last part again.
Sure.
This whole thing with the temp and the 0 after you subtracted that line. Okay.
I think I'm making it too complicated too early. So let's skip that. Okay, let's.
Okay. Well, now we can't hear you at all. Hello? Oh no.
You can hear me now, I take it.
Okay, now we can hear you.
I wonder why. I just unplug my speakers. Fine, I don't care. Right, that's fine. Okay, as long as
you have external speakers plugged in.
I just unplug. Say that again.
When you have external speakers plugged in, sometimes the mic, like the sound cancellation or whatever, it like echoes or something.
Okay. Well, maybe
it's happening.
Maybe it's better to leave them out. Okay, fine. So as I said, I don't want to go too much into the scope thing. The scope in Python. So let's just. I won't do anything complicated again. We can do that later. I'm making it much too complicated, more complicated than it is. So let's do that. And let's not even worry about these guys up here. As I said, let's not do any fancy scope stuff at the moment. And we'll just stick with this. This is as much as we have to, this is all we have to understand. And we have to understand this, of course. And like that. There. And the other stuff. Okay. Okay, so the reason I did it the reason we started off doing this before we went off on a tangent is that we're saying that this doesn't matter the relationship different names. Nobody cares.
We didn't get any of that.
It doesn't matter if the are you getting it now?
Yeah, but we didn't hear any of what you just said, that big long sentence.
No, that's fine. I'm going to do it. I'm going to do it again. There's a little thing that appears on my screen that says that I'm talking, and if I don't see that, it means you don't hear me. So now I know now that I know when you're not hearing me. Good. Okay, back to what I said. There's no relationship between the argument names and the parameter names. The only relationship you have to maintain is the data types. They have to have the same data types. So if your function is working, if your function does stuff to integers, then you better pass integers to it. Now, sometimes if you're just doing addition, if you're doing add the way we did before, the fact that strings and integers have the same function, the same plus function, or the plus sign operator, lets you get away with using the function for strings and integers. But it doesn't. But that's only because they use the same function or the same operator. The plus function adds numbers and also concatenates strings. So that's why we could do that. And we could. Oh, we can do this with strings also, because you can. I think. Okay, let's wait for next week to do strings. I'm just going to talk about integers from now on. Okay, how is everyone happy with this thing right now? What we got here?
Can we go through it and explain like line by line what it's doing?
Okay. All right, let's go from lines 3 through 8. That's the definition of the function largest. So it has two parameters, m and n. Now, you're comparing m to n. If m is greater than n, you assign temp to m. Okay, if it's not greater than that, if it's less than or equal to it, yeah, let's do this. Yeah, let's do this as well. So I'm going to do print largest m comma m like this, and print largest n comma n like that. Okay. Now, what the function is doing is comparing the first parameter and the second parameter. If the first parameter is greater than this parameter, it assigns the first parameter to temp. Otherwise, it assigns the I can't even say it. It finds this. I'm sorry. If m is greater than n, it assigns parameter to temp. If m is greater than n, it assigns m, the first parameter, to temp. If, on the other hand, m is less than or equal to n, it assigns a second parameter, n, to temp. That requires a little bit of explanation. Let's go through this one. What does it mean for this to be false? If it's not the case that if it's not greater than n, what can you say about the relationship between m and n?
M is less than n?
That's not all of it. Okay, let's say that m equals n. Would the condition on line 4 be true or false? M equals n?
It wouldn't be
opened up.
I beg your pardon?
It wouldn't be met at all?
No, look, if m equals n, let's say m is n, would the condition m greater than n be true or false?
False.
Yes, that means you'd execute the else part. So that means that what you're returning, what are you returning? You're returning a number.
It wouldn't just be those two numbers in a row?
Well, no, I'm saying how would this characterize the two numbers? The number it's returning is a number that's not, it's the number that's great. It's what the number it returns, the number it returns is greater than or equal to the other number. If this, okay. let's see. Let's take some numbers here.
Could you run it and then we can break down what
Okay,
the output is?
sure, let's run it. That's always a good thing. Okay, there's our output right there. Right here, let me move this up so you can see it a little better. Oh, you can't see it all now. There's your output right there, 17, 17, 12. Okay, let's do the first 17. So M is 17, N is 12. And so since M is 17 and N is 12, it's going to return M because this part's going to be true.
Correct.
Now, on this one,
So M is 17, and then does it assign temp to M? And then it returns.
it assigns M to temp, not temp to N.
It assigns. You said temp to M.
No, M to temp.
M to temp. M to temp.
Right to left.
It assigns M to temp, and
Yeah.
then when it I'm confused. When it says it prints M and M, but isn't M now temp?
It does not print M and N. It prints the largest of the two numbers. It prints the thing that's returned in the return.
Okay, it prints the function.
It only prints one thing. Yes, you see, you're invoking the function, and you replace the function call with whatever value of temp was temp. Whatever value temp had is what you print.
Whatever value
Correct.
had, you print.
Remember, the value of the function is the thing that you return in the return statement.
The value.
Let's do it again. Let's take this out, and you're going to get nothing or whatever it was. If I take that out, let's see what prints now.
So that return temp takes you back to line.
Okay, so it prints none again because it's not returning anything.
So when you have line 8 takes you to 13.
Line 8 takes you to 13, 14, 15, and 16 sequentially. Because you return where you started off from. So you start off from line 13, you return back to line 13. When you start on line 14, you return to line 14.
So it's I'm lost again.
It depends on where you start. If you start on line 13, you return.
Well, like, I understand that it returns to that, but I'm trying to understand like what the programs do. I understand where it goes now. Like I understand return temp takes you to line 13 because it's print there. That's printing the function. But like I'm trying to think of the function and how it's working, and it's not.
It returns the greatest of the two numbers, or returns
But
the
like
number.
if we assigned the greatest one to the value of temp, then
Yes.
don't we have to print temp in order to get that value to print?
Again, remember how it works. You're not printing temp. You're replacing the function call with the thing value of temp.
So you're replacing. So
Largest. Yes, go on.
So you're replacing largest with temp?
No, you're placing largest open parentheses M, comma, N, close parentheses, not with temp itself, but with the temp's value.
So don't forget, Randy, that this is also working within that if and else statement.
Yeah.
So that's why you have the values of the temp will change, because if it's one thing, then temp will be a certain number. Otherwise, temp will be another number.
Okay. So temp it's a fluid number. It's not going to be the same anytime.
Because of that if else statement.
Okay. And then like, so like I'm confused when you print largest of M or N.
M and N.
M and N. And
Largest of M and N, yes.
But what did we need to assign temp for so that it could fulfill certain conditions?
Well,
I'm sorry.
Well, okay, you could do it like this. The reason you did it is so you had only one return statement. Well, let's see. So you only have one return statement. But let me save that again. Let's do that with another copy, and we'll do it a way that perhaps makes a little more sense to you. So let me call this for 7. And there is I guess a convention in something called structured programming design where you only have one return statement. Now, in a really small program like this, it doesn't matter, but I'm accustomed to doing it that way, where I only have one return statement in my program. So
I get the one return statement. That makes sense to me. I understand it completely fine. I don't understand the value of temp. Temp is what's confusing me. I get the return is only, so it's going to return temp either way because one of the conditions is going to be met.
Yes.
And depending on which one is met, that's why I don't understand why the print has N and M in it, but we assigned the larger value to temp.
Because
like we got the larger value, we assigned it to temp. Now what happens to temp?
Temp is destroyed when the function ends. It's simply a local variable. It's local to the function. When the function is created, when you invoke the function, you copy the argument to the parameter. First argument goes to first parameter. Second argument goes to second parameter. Now, you copy the value, not the actual object. They're different values. I mean, they're different things. Then you test. If m is greater than n, you return m. This is a two-step process. What happens is you return back to where you invoke the thing, which is right here, and you replace the function call with the value that you returned. So the value of the expression that I'm highlighting, largest open parentheses m, comma, close parentheses n, I'm sorry.
So that's being replaced with m if that first condition.
With not with m itself or in itself, with a copy of the value.
Okay, so this makes sense. The way you just did it makes a lot more sense.
Yes. Well, good.
That thing throws me off. Cause like I don't understand the I don't know.
Well, but that's okay. I'm not really okay. Let's call it A equals 45 and B equals 54. And then you do. Let's just copy the whole thing up down here again. Copy. Paste. Oops, what happened there? Oh, I don't have to type this over. Oh no. Do I have an undo on this? Not very much of one. Oh, now I got to write these over again. All right. Print largest m comma n. Print largest n comma n. Print largest m comma m. I'm leaving out a parentheses here. And that one. Print largest n comma n. All right, and now we'll do this with A and B, and we'll do the same thing. Print largest A comma B, like that. All right, there's no relationship between the names of the arguments and the names of the parameters. They're simply copied in the order they appear in the argument list. So first argument is copied to first parameter. Second argument is copied to second parameter. The names are irrelevant. Okay, my voice, okay. How does that working out?
Yes.
Okay, so everyone's reasonably happy with this explanation. Okay, reasonably happy is something. All right, let's move on to bigger and better things. Actually, this is about as big as it's going to get. I think you're only going to need.
That's comforting because I'm on the fence about whether I understand this. Bigger and better. Let's go with almost identical.
It's going to be almost identical.
Thanks.
We're taking baby steps, so to speak. All right, let me think. What are we supposed to be doing? Okay, I want to get you the points so you can do your homework assignment. Okay, let me just, okay, I already saved this, so I'm going to do, okay. All right, now a little bit before, actually I have this written down. This is in the notes that I sent you, but I might as well, I'll just write it and explain it as well. What we're going to do is write a function. All right, okay, a prime number is a number whose only divisors are 1 and the number itself. All right, okay, so that's just a definition. Some prime numbers, let's think of something a little, let me think. Okay, let's do a perfect number. A perfect number is a number whose proper divisors add up to the number itself. So the first perfect number is 6, because 6 is equal to 1 plus 2 plus 3. Proper divisor is a divisor that's less than the number and divides the number without remainder. The proper divisors of 6 are 1, 2, and 3, and they add up to 6. The next perfect number is 28. Its proper divisors are 1 plus 2 plus 4 plus 7. That's 6, but same idea. 7, still 6. Plus 7, still 7.
You're hitting shifts.
No, my fingers are too high. Oh, I see what I'm doing. 7. Thank you. I was hitting the shift key too. And those are perfect numbers. Because let's see, 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 1 is 14, 14 plus 4, okay. Those are perfect numbers. I think the next perfect number is 496. The next one is 8,128, I think. And the next one is 3 million or 333 million something.
So its factors add up to it.
Yes, it's yes. So let's write a function that returns true if its parameter is a perfect number and false otherwise. Okay, so here we go. Def is perfect number. Okay. Now, the largest proper divisor a number can have is half the number. It can't be any larger than that. Take my word for it. So I'll just do, let's see, last candidate equals number, int number divided by 2. Okay, why the int? The reason is that when you do division, what's the name? Python automatically converts the result to a floating point number, a decimal fraction, if you will. So converts to a decimal fraction. So what? So it converts to a decimal fraction. And you want to chop that part off. So when you apply the int to a function, or to a number rather, to a floating point number, it simply chops off the floating point number.
So can we go, as you're doing it, like, can you explain what, like, so the first line, we're defining is perfect number as a function.
Yes.
And then the second line, where did last candidate come from? What's that logic behind how it was created?
All right. The largest divisor that a number can have is 1/2 the number. So what we're trying to do is calculate all of the divisors. If you like, let's call it last divisor.
Can it also have a largest divisor as itself?
How can you calculate the largest divisor? You can't just pull it out of a hat. You have to calculate it.
Isn't the largest divisor a number can have it's the number itself?
The largest proper divisor. A perfect number is equal to the sum of its proper divisors. So the last proper divisor is the number divided by 2.
I've never heard of a proper divisor. So is the proper divisor like not 1?
Yes, 1 is a proper divisor of every number greater than 1. The proper divisors of, as I showed up here, the proper divisors of 6 are 1, 2, and 3. The proper divisors of 28 are 1, 2, 4, 7, and 14. Let's do another one for you. The proper divisor.
But I thought you said the largest proper divisor was 2.
No, I did not say that. I said the largest proper divisor a number can have is 1/2 of the number, is half the number. That's what I calculate on line 6. See, number divided by 2. That's how the largest divisor this thing can have. The last let's call it the last candidate then.
Oh, like 7 and 3.
The largest proper divisor 7 can have is 3. Of course, 7 has only one proper divisor, 1.
No, but I'm saying in 28, the largest proper divisor that it has is 7.
No, the largest proper divisor is 14. That's why it's right here. See, 14.
Oh, okay.
The largest 28 divided by 14 is 2.
So the largest proper divisor that 14 would have would be 7.
Yeah, but we're not trying to count. Yes, that's quite right. The largest, yes, you're right about that. You're absolutely right.
Professor, do we need to put a colon after number? Where it says is perfect number?
Yes, we do. We certainly do. Again, well, just remind me. I'm not going to go through that explanation again. Yes, thank you for reminding me. Thank you. Otherwise, we'd have got, that's great. Let's close this window so we can have a different output window for the thing. They're good. Okay, where were we? Okay, so that's line 6. We're getting the last possible divisor. It might not divide the number. So let me put last possible divisor. So the last possible divisor we can have is the number divided by 2. Now it might not be it, but it's a big, so we don't have to go there. So we just do 4 possible divisor. Let me in.
Should it say last possible divisor? Should it say last possible divisor?
No, we'll get to that in just a second. No, this is we're looking at the possible divisors. We're going to do this in a range statement. Range 1, comma, last possible divisor plus 1. No, it's like that because, yes.
So like to explain this step again, we're going from, so last possible divisor is that number over 2. And then so that's all under the definition of imperfect. Okay, now I'm lost.
Yes, you notice how it's, yes, I'm sorry, maybe I don't think I have to indent this, but we'll see. I only have to indent it after that.
So what is sum in here for now?
What is the function returning? It's returning the sum. Oh, I'm sorry. Okay. Remember, a number is perfect if the sum of its proper divisors is equal to the number itself. In order to do that, we have to calculate the sum of the proper divisors. That's what sum is.
First you put in possible divisor, now you put in sum, but there was no explanation for when sum was coming in.
I forgot to put sum in.
So it has to go after last possible divisor.
It doesn't have to go after it. I can put it up here. It doesn't matter. Okay, see, you only need sum when you're trying to calculate, when you're trying to add something to sum. We're only going to add anything to sum inside the for loop. See, the for loop is going to calculate the sum of the proper divisors. So as long I could put sum on line 6 or sum on line 7. I just have to have it initialized before I get inside my for loop. But yes, it doesn't matter. It can be on line 6 or line 7. It just has to have a value before we get into the for loop. No, our for loop is going to go, our possible divisors are going to go from 1 to the last possible divisor. And so all we got to do is find out if that divides the number. Okay, and that's just an if statement. If number modulo possible divisor equals 0, colon, sum equals sum plus possible divisor. I think I did that correctly. Good.
Can I ask a question?
Yes.
So like, you know how when you're in like second grade and you're getting a word problem and
Yes.
you are trying to figure it out and your teacher tells you, here's what you do. You take this number and this number, you take all of the information that you know and you put it aside. And then you try to set up the problem. Like, that's where I feel like I'm not understanding things, because I get the information of what we're adding, but like, we're just making it up as we go along. And
No, we're not. You can see up here, right
I
there.
see that. I understand that part. The math part makes sense to me completely.
Yes.
But like the word, like we're not coming up with, so like when you're figuring out a physics problem, you take all of your variables and you put them out like in front of you. And
Yes.
then you like use the logic in your head, in your mind. But like we're going in line from top to bottom, and I'm not getting like, I'm not understanding the logic of this. I'm not.
Logic is that you have to look at all the possible divisors from 1, let's say the number from 1 to the last possible divisor. What the for loop does is it generates, as you go through the for loop, it's going to assign the possible divisor is going to get all the values that could possibly divide number. So it starts out at 1.
Say that one more time. I didn't even.
Possible divisor, the for loop will assign to possible divisor.
For loop.
The for
is
loop.
assigned to possible divisor.
The for loop will assign to possible divisor all the numbers that can possibly divide the parameter.
From 1 to the last possible divisor. And the last possible divisor is that number over 2.
Yes.
And then it's going to do that one beyond it.
No, it does not do it one beyond that. It does it it stops at last possible divisor. It's the largest number that possible divisor will be assigned is last possible divisor. You have to put the +1 in there because of the way for loops work. The for loop does everything from the first value to the last value -1.
So it excludes the last value.
Which is last divisor, possible divisor +1.
Okay. And then the next one is if the number modulo possible divisor is equal to 0, which means that there is no remainder.
Yes.
And that if is only for the possible divising thing. And then sum plus possible divisor is that value is assigned to sum. And so that's 0 plus, for the first one, it's 0 plus the possible divisor. And that's all we got so far.
Yeah, that's about it. Well, that's almost all of it. But the purpose of the, yes.
I didn't mean to interrupt you, but the possible advisor that you have on line 8 has an additional S.
Possible divisor.
Nope, the first instance.
That's 3 S's, yes.
And it's also misspelled on line 10.
It's spelled divisor in line 10.
Okay. All right. So far, so good. We haven't started to compile it yet.
Quick question. We don't need a colon between fors statements and if statements, or we do?
We do.
Okay.
Fors, ifs. Okay.
Just about every other block you can think of. So this is a function block. That's a for block. That's an if block. You always got to put a colon there. Okay. back to the logic of the thing. The logic of the program, of the function rather, is to figure out some way to get all the possible divisors. Now, the reason that this does not quite work the way a math problem works is that on occasion the number of possible divisors is huge and you don't want to write them all down. Here, let me just find a big, let me think. Okay, I think 496. Let me just look.
It's like sometimes I don't understand where your thinking is coming. Like whenever I'm trying to solve a problem, I like ask myself questions, and or something. I like maybe it's just because it's a new language and I don't get it, but it's frustrating.
All right, this is where the thinking is in this. You want to find out if something's a perfect number. That's where you're trying to get to. In order to do that, you have to look at all the divisors. Because again, a number is a perfect number if the number is equal to the sum of its proper divisors. Now, this function is true if it's a proper divisor and false if it's not.
Can you repeat that again? I'm sorry.
Okay. A number is a proper divisor if the sum of the numbers proper divisors is equal to the number itself. Now, in order to find out if something is something's a perfect number, you have to look at all the numbers proper divisors and add them up and then compare them to the number. The first thing you have to do is calculate the sum. You have to calculate the sum of the numbers proper divisors.
The proper divisors again are a number that divide the number evenly?
Without remainder.
Without remainder, okay.
Yes, without remainder. So what you could do, which might make it a little more palatable to you, but we don't know how to do it yet, is generate all the proper divisors first and store them somewhere and then add them up. Okay. We can't do that. And it's also an extra step, so we're not going to do that. So the idea of this function is to go through and look at all the numbers that possibly can divide our number, our parameter. And that's what we're doing here. So this for loop allows us to look at every possible number, any number that possibly can be a proper divisor of the parameter. If that's what the for loop is looking at. Excuse me, I almost spilled something. It's looking at all the numbers that can possibly divide our parameter. Okay. The only way we can do that is by having this. Well, there's many ways, but the easiest and fastest way is to simply generate the divisors with this for loop. And that's what the for loop does. The for loop is going to start at 1 because that's the smallest possible. That's the smallest proper divisor. And it keeps on going until it gets to the last possible divisor. And you have to put the +1 there because that's the way for loops work.
So it's dividing the number by 2, and then it is getting. So can we go? So like say for. Okay, I don't know.
Line 7 calculates the largest number that can possibly divide our parameter.
So if the number is like say 7, the
largest proper divisor is 3. The largest possible number that can divide divide 7 is 3. The largest, that's not. There's only one number that can.
So yeah. I get that. Like that's not even a question.
Yes.
But my question is the program when it's doing that. So like it's going to execute the first line, it's going to execute the second line, but after it gets to the third line, it's not because it's not going to have a 0 remainder.
You mean line 8?
Or yeah, like line 9. Well, line 9.
Okay, line 9. If it doesn't have a 0 remainder, then it's not going to execute line 10. If it does have a 0 remainder, it will execute line 10.
Okay.
Not all the numbers in the range 1 to last possible divisor will divide the number. That's why they're called possible divisors. We're
So
looking at,
like in the case where not the number is 7, it's going to take the integer of 7 over 2, which is 3.5. But that's not an
no,
integer.
it's 3.
Oh, so it's gonna like take away the half because it's it just cuts off the decimal of the float,
Yes.
and then it's going to for the and then for the last possible divisor in range of 1 to, so then that number is 3, right?
Yes.
And then the next one, so if 3 over last possible, or if 7 over 3 has a remainder of 0, which it doesn't, then it's going to stop.
Yeah, well, it's going to stop as soon as it gets to 3, yes.
Yes, okay.
Not because it
I
doesn't
understand now.
But the whole purpose is you have to look at all the possible divisors and you add the ones that actually will divide the thing without remainder. And when you get one of those numbers, you add it to the sum.
Okay.
Okay, now once the loop ends, if everyone's reasonably happy with that, notice that I have to put my insertion pointer under the 4 because I want these to be at the same level. I don't want to execute this line here on line 12 until the loop ends. So I'm going to put, now then I just need to return sum equal to number. Now this is a Boolean expression. Notice you have 2 equal signs. Now, the only time it's going to return true is if sum is actually equal to the number. So in the case of 28, it's going to return true. Let's try it. So here we go. We'll move this down here. We'll just do print is perfect 28, like that. And so the function, the thing it's not returning sum, it's not returning number. It's returning the evaluation, if it's going to evaluate this expression, which is a Boolean expression. And so it's asking the question, is sum equal to number? If that's the case, it's going to return true, otherwise it's going to return false. I'll try to explain the logic behind these a little bit better.
So would you say, Professor, that the function that you've created here essentially is in itself an entire Boolean expression to test the Boolean expression? To test whether something is a perfect number?
That's what it's doing, yes.
Okay.
And the only way that you can test that something's a perfect number is you have, let's look at more abstractly. The only way you can find out if something's a perfect number is you have to add up all of its divisors. However you do it, you got to add all the divisors. Then, what do you have to do? Sorry. You have to add up all the divisors, and then you have to compare it to the number. So the first step here, we add up all the divisors. So we're adding all the divisors, and then finally we compare it to the number. If you don't like this expression, let me do this let me do this perhaps the way it'll make more sense.
So if only in the instance that these conditions of your defined function work, then will you have a perfect number?
Yes.
Okay.
I think it's a little bit better. Return true, else return false. Oopsie again, false. There, that might make a little more sense than what I had before. So if the sum of the proper divisors equals the number, you return true, else return false. Let's see what we get out of this. It might not compile at all. Okay, it's a perfect number. But whenever you're testing something like this, you have to think, well, maybe I made a mistake, and it's always going to return true. So you have to do the next thing, which is,
You have a semicolon? What is that? Or, yeah, a semicolon.
Oh, that's a mistake. That's, as I said, I get mixed up with languages. But there are other this just happens. When you know a lot of when you know more than one language, you kind of get mixed up sometimes. That's the opposite of my not remembering to put in a colon after everything. I put in an extra semicolon. There. Now this one should return false because 29 is not a perfect number. Let's run that. And so we get a false there.
So I have written the same things as you have, but mine isn't working. It's saying that name error false. Oh, so we have to have capital.
I'm sorry, yeah, it's a case sensitive language. Well, I don't have any capitals. If you have caps, you got to put caps in.
Yours are caps and
Where?
True and false.
Oh, those, yes, but that's not me. That's the I mean, yes, those the true and false, that's Python. And so yes, you absolutely have to put true in capital T and capital F when you do true and false in Python. Again, I'm not going to beat that one. I was going to say other languages have different standards. Another language. Now, okay. Now, one thing is, do you know? Okay, a prime number is the number whose only divisor. A prime number is a positive integer greater than 1, whose only divisors are 1 and the number itself. Can you formulate a definition of a prime number in terms of proper divisors? What are proper divisors? What are the proper divisors of a prime number?
Itself and 1.
Well, no, it's only divisors just 1.
Never mind.
No, yeah, no, you're right. But see, the number, yes, the way that people usually define a prime number, they say a prime number's only divisors are 1 in the number itself. That's correct. But if you say it in terms of proper divisors, a prime number's only proper divisor is 1. So now we have a function that allows us to calculate prime numbers. Let's write a nice.
Tell me again what the proper divisor is. What a proper divisor is?
A proper divisor is a number that's less. A number's proper divisor is another number that is less than the original number and that also divides that original number without remainder.
It's less than the original. So its main definition. It's like it's stipulating condition there. The reason why itself is not a number is because it has to be less than that number.
Yes.
Okay.
All right. So one way you can define a prime number is by saying a prime number's only proper divisor is 1. Or another way to do it is to say that the sum of a prime number's proper divisors is 1. So we actually have another way, not a very good way, but another way of calculating whether something is a prime number. And okay, I was going to do that, but let's not, simply because of what? We've already got the idea here. I don't need to beat this to death. Yes. Okay. Now, let's see. It's 8:58. I think you have enough to do your homework, but let's go on with this a little bit further.
Professor?
Yes.
I noticed that it says homework 7, problem 2,
Yeah.
and the description says to use the program that we wrote in problem 1 of homework 7, but homework 7 problem 1 has not been posted.
Somebody forgot to do that. Okay, I will post it in just. Okay, let's do this. Let's do another 20 or 30 minutes of this because we haven't taken a break, and then we will go. I will. It's there. I just haven't made it visible yet. And I'll make the thing visible. It's actually the homework assignments are just simpler versions of what we're doing right now. So don't worry, if you can understand this, excuse me, you'll be able to do the homework. Okay. It's much simpler than proper divisors, though the same idea. Where was I? Okay, so everyone is reasonably happy with this. No complaints. Could be worse. Okay, so let's list all. Let's just print out all the perfect numbers between 1 and 1,000. We should be able to get through that very quickly. So I'll do 4 number in range 1, 1001. Let me see. Let's do, I think, let me see. Yeah, 1001. Yeah, that should just get 2 of them. And so we'll just do if is perfect number, colon, let's see, a print number. There we go. So there's how we would use the function. It only has one. Okay, we got to do one with 2 parameters. Yeah, 2 parameters. Okay. All right, let's see what we get. We should get 3.
You need to put a colon on line number 22.
I just left that off to see if you would see it. I'm going to define all my mistakes as lessons for you. Okay, let's go here. Run. Okay, 628 and 496. The next one I think is 8,192. So we won't do that. That's good enough. So there you see how to define the thing up there. Let me see. Okay. Okay, I didn't want to, okay, let's just leave it like that. No. Let's call it candidate. I just do this because I want you to, there's a difference between the parameter and the argument. Now, I kind of confused that in those other examples, and I said I wouldn't do anything like that again. But I just want to make it clear that they're different. That the argument is not the same as the parameter. But we got 2 uses of for loops here. The for loop from on line 22.
So in the first one, the argument is number, and the parameter is perfect.
No, no, that's the parameter is the name of the function is perfect, and the parameter is number.
So the parameter is number. Where's the argument?
The argument is candidate.
Well, I mean, like on the first one.
There is no argument. Well, there's no argument because there's no function here. And I mean, there's no function. The argument is where you call something an argument when you invoke the function, you pass the argument to the function definition, and you copy the value of the argument to the value of the parameter. So candidate is the argument, and number is the parameter.
Huh.
It's just new. I mean, some books call it the formal parameter, the actual parameter. Other books call it the argument, the parameter. Depends on what book you read. I like to say argument and parameter because they're different from one another, rather than saying formal parameter and actual parameter because they have a common word. But again,
so number is the parameter.
Number is the parameter, yes.
What now? Like we didn't have candidate before. So what was the argument before we had candidate?
It was number.
So number was the candidate. So number was the argument and the parameter?
Yes, but remember they're 2 different things. You copy the value of the argument to the value of the parameter. It doesn't matter if they have the same name or different names. All that's important is they have the same data type. It's integer to integer. These are both integers. Candidate's an integer. A number is an integer. That's all that matters. The name
So
is
if
not,
we had for number in range of 1 to 1001, the number there would be the argument. And the number up top in the definition thing is the parameter.
yes.
Okay.
Yes. Okay. Any other questions on that one? All right. So we're not going to run this again. You can see how it goes. So this is the 9th example. Let's knock that out. Okay. And I won't do any more numeric examples or arithmetic examples once we start strings. We'll just do string examples. Okay. So this is test functions 9. Test functions 9. Okay, now we're going to do, those are perfect numbers. Now we're going to do friendly numbers.
Friendly.
Friendly numbers, yes. Okay, two numbers are friendly numbers if the sum of the proper divisors of the first number is equal to the sum of the is equal to the second number, and the sum of the proper divisors of the second number is equal to the first number.
Can you
And
give?
I'm sorry?
I thought we weren't going to do any more numbers.
Well, I don't have anything else. I don't have strings. I got to do numbers.
No.
But I say next week we're going to start on strings, and I won't do any more
Oh.
numbers.
As
Yes.
you read the definition, can you put them on the screen for so we?
I will do even better than that. I will do better than that. Here's the thing. I'm not making this stuff up.
I've never heard of these things, though. I really haven't.
Friendly numbers.
I've taken a lot of math classes.
Okay, I'm not gonna go there. Oh no, I'm sorry, not friendly numbers, amicable numbers. Okay, amicable numbers.
This is not like math.
I
Exactly.
know, exactly. Like, I've taken calc, and I'm not, this is like different things.
It's number theory. You have to take classes in number theory.
Is that like CS104 is like math or computer science?
No, they don't get there. No. Okay, they're amicable numbers, not friendly numbers. Friendly numbers are different. Okay, the smallest possible friendly numbers are 220 and 284. But okay, they're amicable, not friendly.
Isn't amicable a synonym for friendly?
Yeah, and that's they're slightly different. They I'm not gonna let me just in the 19th century. Forget it. Don't worry about it. There's just a lot of there's just a lot of relationships for numbers, and you just can look them up. Friendly numbers, amicable numbers. There's tons of them. There's tons. So we're going to do amicable numbers, not friendly. But anyway, my point is, the point of this is you can always look up the definitions that I give you, but I will put the definition in the comments for you. And fortunately, that gentleman asked the question because otherwise you'd have looked for friendly numbers and you'd found a completely different definition. That's good. Okay, let's go back to this other stuff. And we're going to call them amicable. They're amicable. Great. Okay, so let us write ourselves a flow. You already got a copy of this. So we're going to write a number called sum of proper divisors. Sum of proper divisors. And so I don't need any of this stuff. I just return the sum. That way I can reuse the code. Return sum. Good. So that wasn't a magic trick. That just returns a proper divisor. Now, if I wanted to, I could do this, of course. I could read, I did want to do this. So let me do this too. If I'd been thinking I would have done this, so I do def is perfect. It's perfect. It's lowercase here, perfect. And I would don't worry. In fact, I was trying to do this and I got kind of messed up. But anyway, so I'm on the right track. Here we go. Now, all I do is this. Return, I'm just going to do it this way because we're in a hurry. Return sum equals, number equals sum of proper divisors number. So I always like to do that, to write one function in terms of another function. That's really recognizing when you can do that is very, very important, because it means you don't have to keep writing the same code over and over again. It's called code reuse. So in order to determine if something's a perfect number, I reuse my sum of proper divisors function. Great. Okay. Now, having said that, let us go do a couple of other things. And now this one is going to, let's see, it's import. I think it's import from random. Oh no, it's backwards. From random import rand int. And let's do from rand. Well, we don't need a seed. Who cares? Okay, what I want to do is I'm going to do another while loop. And I'm going to keep generating pairs of random numbers between 200 and 300 until I get some amicable numbers. All right. Okay, let's take this out. Now we're going to do our amicable function. So I'll do def is amicable. Let's see, let's call it number 1 and number 2, like this. And so we just do, okay, we do sum1. I forgot the colon again, but anyway, sum1 equals sum of proper dot. All right, let me do the logic thing again, since you're wondering how this is going to go. All right, two numbers are amicable if the sum of the proper divisors of the first number is equal to the second number, and the sum of the proper divisors of the second number is equal to the first number. So before we can do those comparisons, of course, we have to calculate the sum of the proper divisors of both numbers. So that's the first step. So I do sum1.
Could you say all that again and slower, a little slower?
Sure. Let's go back to the definition. Let's see. Amicable numbers. An amicable pair. An amicable pair consists of two integers m and n for which the sum of the proper divisors of one number equals the other. So this, okay. So that's the definition. You look that up on Wikipedia as well.
So like the numbers, the sum. Can we have an example?
You wouldn't know it was an example unless I told you. But the sum of the proper divisors. Okay, an example is 220 and 284. And I think, yeah, there's 228, 220 and 284 are amicable numbers.
So 110 plus 110.
Is that the sum of the proper divisor of 220?
Is it?
No, I don't know what it is. But I do know the sum of the proper divisor of 220 equals 284, and the sum of the proper divisor of 284 equals 220. Oh, actually, I do know what the sum of the proper divisors are. The sum of the proper divisor of 220 is 284. And the sum of the proper divisor of 284 is 220. Because I know these are amicable numbers.
So can you read the definition? So
this is what he's saying. All the numbers that divide into 220, if you added them up, it would equal 284. And
okay.
all the numbers that divide into 284, if you take those numbers and add them up, they will add up to 220, making those two BFFs.
Well,
so
yeah,
amicable numbers are numbers that whose divisors add up to themselves.
No, those are perfect numbers. That's perfect numbers. Amicable numbers add up to each other. That's why they're amicable. Right?
Oh, it's a relationship between two numbers.
Yes.
Okay.
All right.
Amicable.
Let's okay. As I say, no more math, no more numbers after this week. So we're just going to do strings, and we'll do a lot of stuff with strings. One thing we'll do is we'll
Hello
count.
everyone and welcome to a new lecture. In this video we are going to talk about amicable numbers. So what are amicable numbers? Well, basically amicable numbers are two numbers such that each is equal to the sum of all the natural proper divisors of the other. So if you have two numbers such that each of them is...
I knew you'd like that. How do I get rid of this?
Ask Siri.
There we go. Okay. Anyway, where were we? Okay, so we want to write a function that will determine whether these two numbers are amicable. I say amicable, they say amicable. Fine. Okay, so the first thing we got to do is we got to calculate the sum of the proper divisors of the two numbers. So that's what we got our function sum of proper divisors for. You simply say sum1 equals sum of proper divisors of number 1. We got to do this because, again, we don't know. The only way we know two numbers are amicable or amicable if we compare the numbers, we compare the proper divisors of one number to the other number. Okay, now let's do this. Okay, so sum. I'm going to do this with a compound if statement because I want you to. I'll do it both ways. What the heck? Sum of proper divisors number 2. Okay. Now, this is the way that you will do the return statement after you've been writing programs. Well, let's do it before that. Okay, just do this. If, let me see. What's the easiest way to do this? Okay. I can do this several ways. You tell me which way you like best, which way makes the most sense. All right, now this is, for me, the simplest way. And we're going to, okay, sum1 equals number 2 and sum2 equals number 1. That's one way. Let's call that amicable 1. That's just a compound statement. A compound AND statement is true if both components are true. Now, let's do another one. It's 917. This might be our last example. So I'm sure that, okay, let's do this again. And this time, we'll do it with an if statement. Well, let me think. Okay, the if statement is just as bad. If sum1 equals sum2 and sum2 one second, I hit the wrong key. Okay, now we got to put the colon in. See, I didn't forget this time. Return true. Else.
Did you mean colon instead of semicolon?
Okay, I forgot only half then. I half forgot. Yes, it's supposed to be semicolon. Okay, yes. Okay. All right, that's the second way of doing it. The if statements are the same. Now, let's suppose you wanted to do without those compound. I don't know how to do without a compound statement because both comparisons have to be true. Sum1 has to equal number 2, and sum2 has to equal number 1. That's what makes it amicable numbers. Okay. Now, a third way would just be repeating this and somewhat. But this is your choices. There's not really a way to, well, yeah, I guess there is. Okay, let me do it a third way. And the third way, however, has simpler conditions, but more return statements. So let's do it a third way. I believe that's the name of some political organization. The third way. All right, so here we go. All right, so let's take this stuff out. And this would be the third way.
Professor, does the F in false have to be capitalized?
Yes, it does. Yes, it does. Yes, it does. Thank you so much. Okay, this is the
Getting
third
an
one.
error under else.
You're getting an error under else.
Yeah,
I
it's
don't know
saying that
why.
it's oh, okay, it's not indented the right. Well,
Okay. now
the
here we-
thing is like if I indent it, it won't indent the right amount of times.
you don't have to, the spacing doesn't, look, you got to just get it a little. Let me just try this one. If I move this up here like this, it shouldn't give me an error. Let's just compile it and see. And we'll go down here. The indenting, and it's really, I guess it's kind of a slippery slope, but the indenting has to be enough so the compiler knows that it's not aligned with something in another block, that's in another block. So the compiler would get upset if I did this. One moment. I'm hitting the. It upset if I did this. It might be upset if I did this, but it probably wouldn't be upset if I did that, if I did it just a little bit more. And it certainly would be upset if I did that.
But like mine is not working when if is under else.
Well, I don't know what you have then. The if should be under the else.
I know that's where it's at.
Well, where's your return statement though?
It's indented 1.
Try to indent it a little bit more than 1. As I said, it's a slippery slope exactly how far you have to indent it. Indenting it just to the colon would probably be enough. That should be enough. 1 is not enough. It's hard, as I say, I can see it's iffy. Sorry, that's backspace.
Yeah, it's still not.
Okay, that's certainly not enough. That probably is not enough. That may be enough. That certainly is enough. And this is without doubt enough.
Yeah, but the issue I'm having is it's saying that if is unexpected, the indent is not right.
Well, okay,
It's directly under some, like yours.
yes. Do you have a colon after is amicable to? Oh, I'm going to make this is amicable. You know, this is amicable 1, is amicable 2, and now we're doing is amicable 3. And then we'll be done, and then we can go over the homework. Let me see, backspace, 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 backspace. Okay. All right. I can help you with your program after we do this. I'm going to send you these examples after class, and then you can send me your examples. We can share. I can share your screen again. Let me ask you something. If I stop sharing, and will you share your screen with will your screen be shared with everyone?
Yeah.
Okay. Well, let's see what.
I got it working now. What I needed to do is I needed to take away the spaces above on some and some too.
Yes.
And turn them into tabs.
Okay, great. All right. So let's do the simpler. We'll do the simpler. What I'm doing is this third example is I'm trying to get rid of see, you have compound conditions here. You have blah, 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 and blah, blah, blah. So I'm going to get rid of the ands. So now we're going to get rid of the ands. All right, so just say if someone is not equal to number 2, return false. If some 2 is not equal to number 1, colon, return false. Okay. All right. That means now, what does it mean? If you get down to line 38, it means that both of these conditions are false. What does it mean to say that both conditions are false? Sum1 not equal to number 2 is false if sum1 equals number 2. And sum2 not equal to number 1 is false if sum2 equals sum number 1. All right, let me do my last magical trick. And okay, I do have one more way to do these, I think. Let's make sure these compile first. Okay, they work good. Or they almost, well, okay, we're going to test these with the actual amicable numbers. All right, so I'm not, okay, where is it? Yeah, there it is, function 9. All right, there's one more way to do this. And that'll be it. Let me ask you this, is doing this, let's see, we've done this 3 different ways. Is this confusing?
Yes.
Okay. Okay, well, the
I
reason,
understood the first way.
I'm sorry?
I understood the first way, but now I'm just copying.
You don't understand the second way?
Or
All
the
I did was take the condition here and put it in an if statement.
I just haven't had time to really even look at it or think about it. So
Yeah, but I'm going to send these to you tonight, right after class. You will have them, I promise you. I will upload them again. And the same announcement I sent to you this afternoon, I will send you right after the class is over. But it's possible I might be struck by lightning. That's true. And so it's best to get them, what is it? Make hay while the sun shines, I believe the saying goes. So you never know. So this is the last way. And you can think about them as you attempt to sleep. Okay. And this all I'm going to do is I'm just going to pin. If it's not the case that sum1 equals sum2, I need another parentheses here. Return false. And we just do this down here as well. If it's not the case that sum2 equals number 1 equals number 1, that's not what I wanted to put. Let's get this in here. Where's the equal sign on this thing? Ah, there we go. Okay. I need another parentheses. There we go. Okay. Good. That should be enough for everyone. Now let's test these. So we'll go into here, and we'll just do print is amicable 1 220, 284. Print is amicable 2 220, 284. Uh-oh, something's wrong. Oh, I have 2084. Okay. And we'll be finished in just a couple of minutes. Whether it works or not, we'll be finished. I'll do print is amicable 3 220, 284. And print is amicable 4 220, 284. Now, as far as I know, this should give us 4 trues. But what do I bet I could be wrong. All right, let's see what we get here. Okay, so obviously I don't know how you do. Oh, okay. That is, I did not know, I should have guessed. That's the negation operator in C++. This is a negation operator. I assume this is a negation operator in Python. I wasn't thinking again. Okay, here we go. And we're not, I think we have an infinite loop somewhere. Yeah, it's not ending. Ah, great. Well, that's a sad, sorry state of affairs. And let's, all right, so I'll make it, oh, there it is. One moment, let's run it again. I still think we have, there's something wrong. It shouldn't take that much time to calculate the proper divisors of those small numbers. But let's see. I got some output before. Why is it taking so long? Well, too bad. You know about that? Well, okay, that's we know that unless I've written sum of proper divisors incorrectly. Sum equals 0, last possible number, blah, 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 return sum is perfect. We don't need that. Let's just delete is perfect. I'm just getting rid of it so I don't have to look at it anymore. And is amicable, sum 1 equals sum of proper divisors number 1, so blah, 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 blah. Last time, because we got to do our homework. We got to get out of here. I'll work on this tonight and see why it's taking so long for us to get some output. But it certainly is. Fine. Okay. Your classwork is much easier. I mean, your homework assignment is much easier than this. Okay, where's your homework? Okay, let's just go here. All right. www.lhccollege.edu and one moment. All right. All right, what do we got here? Well, this is 103. Let's see what we got. 103 assignments. Oh boy. That's problem 1. Oh,
We can't hear it.
I said I forgot to publish it. There. Okay. So someone pointed out that when I said problem 2, okay, write a function, it should be write and test a function, excuse me. Someone pointed out earlier that I had not, that he couldn't see homework 7 problem 1. And I was saying, yeah, that's because I hadn't published it. Write and test a function.
What did you say?
Write and test a function that computes the sum of its parameters digits. Okay, we did this last week without a function. You're just going to add up its digits in a loop, like one of our classwork assignments or homework. I don't remember which it was, but we did do this. Now we're just going to, no, it wasn't a function. It was just it wasn't a function. It was just a while loop in the program.
Huh?
You're going to write a program. You're going to write a program. You're going to write a function. You're going to write and test a function that computes a sum of its parameters digits. And that was a classwork or homework assignment last week, I believe. And most of you were able, many of you were able to do that. And you can look at that aside and you'll see how to do it. Now, as you might have guessed from the last thing we did, okay, so that one's active. And the next thing you're going to do is write and test it. Let's see, this is homework 7, problem 2. Two functions are pals if the sum of the two numbers digits are equal. Write a function pals that returns true if the sum of its two parameters digits are equal to one another. Now this is
Are
not.
they pals or are they amicable?
No, they're pals. Amicable is a much tighter relationship. Now these guys are just pals because the sum of their digits are equal. For example, let's think of two pals. 13 and 4 are pals because the sum of 13's digits are 4. 1 plus 3 is 4, and 4 only has one digit, namely 4. So 13 and 4 are pals. So that's okay. So that's the assignment. All you got to do is write a function from problem 1 that computes the sum of its parameters digits, and you use that function to write this function, just like we did the other one for the amicable digits and the sum of the perfect number, or the sum of the divisors, or whatever they were. Let's see if this thing has ever ended. No, this is something else. Oh, wait. Let's just save it then. Let me just go back to this thing. Wow, this is really, it's either in an infinite loop or it's not doing anything. Look at the program again. Nope, there it is right there. It is trying to print. Oh, I see what I did. Oh my God. The reason it's not doing anything is the print statements are inside this function. There's indenting again for you. Yes. And that is indeed an infinite loop. Yeah, so there's your indent thing coming back to bite you. Okay, now this should work out. It should work a little better. Okay, let's try her again. Does anyone have any questions about the homework assignment?
I'm sure I do.
At some other date then. True, none, none. Okay, something's wrong with the last two of them then. But I will, let's see, is amicable 3, is amicable 4. Let's see. If sum is not equal to number 2, return false. Oh, I forgot to return a value. Okay, that should be return true. Return true. And that's probably the same one with this other one too. Yeah. Yeah, there was I was testing for failure. Okay, now I'll just return true. Okay, now we should get the output we want. And it should be all true. Yeah, there we go. Okay, wonderful. All right, it's now the very witching time of night. Actually, 2 hours before, but anyway.
So I have a question.
Yes.
So we're gonna make a function and define it as some digits, and then of a number, right? And then we're gonna have, and then the sum is gonna be 0, and then we're gonna do like a plus b equals sum.
No, you're not.
No.
You have to you have to extract the digits.
Where are the digits coming from?
The digits are coming from the number. You're trying to calculate the sum of the number's digits.
But I mean, where is the number? Where do we put the number in?
The number is the function's parameter.
I understand that, but where is it, like number? Where is that number going to come from? Like where?
The same place that number came from here. You have to write the function, then down below the function definitions, you give it some arguments.
Oh, okay.
I have a question about office hours.
Yes.
I wasn't able to access office hours on Monday, and will you be posting directions on how to access or what
Okay.
the
Same. Yes, I would. I did not actually. I didn't explain that. The office hours are the same as they were in the announcements when we did the office hours before. There, let me show them to you. But I'll do a formal posting. I mean, I'll just say what they are. This was also another confusing little detail that we did not, or I did not do. What I think I'm going to do. Oh, when one of you actually explained to me. Okay, I'm going to let me think about that. Well, okay, this is what they are right now. I've got to test a suggestion someone made to me. I think it's correct, but I want to try it before I actually commit myself. Right now, let's see here. Where are we? We're almost there. Don't worry. I didn't realize this. I didn't realize a lot of things, but let me get this out of the way. Someone told me, okay, let's see. Today's invites, spelled invite wrong, but that's fine. Yeah, so you can just use this URL all the time. It doesn't change. And so that will get you to our meeting. But someone pointed out to me that I can simply use the same. Okay, first of all, did that answer your question?
It does. I will use that. I tried that on Monday, and it said I had to wait for the host to allow me to enter, and then I waited for 20 minutes, and I assumed that nobody was in it. So
Yes, I forgot what I was doing on Monday, but that was my fault.
Okay.
And what you should do, I mean, if I do that again, just send me an email saying, where are you? I generally don't go anywhere. I sometimes have to go to the post office, but except for that, I'm home all the time. So any email, I should be able to get to your emails right away. And again, I don't remember what I was doing on Monday, but I missed it. I did see your email later that day, because you're Mr. Clark, correct?
Correct.
Yeah, I did see it later, and I sent you something back again. And you were, I guess, off doing something else. Or you'd already tried, and I wasn't around, so you went on to some other business. But just send me an email. I just won't be very far away from my computer. But that's it. What I'm going to try to do, I'm not sure I can do it, but I'm supposed to have this thing, but I don't know when I go here, does this create a new URL every time I use it?
No.
No. You're pretty sure it's the same thing.
I
Well,
mean, so like when you use that Tech Connect thing, that it sets it up every month, every week, like during a certain time period.
Mhm.
And I'm not sure what that URL is. I don't think it's your Zoom ID. But if you set up a new meeting on Zoom every single time, it'll make a new Zoom ID number unless you tell it not to.
Well, that's sort of the problem. I don't know how to tell it very much.
Whenever you set the meeting up, you have to uncheck the box that says generate automatically, and you have to use your personal ID.
All right, okay, I'm going to try that. If not, I'll just get it. I think it's only $17 a month to go with Zoom, and I'll just do that for a month or two.
You don't have to do that. You're like LACCD is already paid for it as long as you sign into Zoom using your LACCD ID.
I tried to do that. It didn't I don't know which ID I don't know which ID I'm supposed to use.
Like it's the one with like laccd.edu.
Yeah, that's my email address. I did that. They sent me an email saying that they wanted me to sign up. So they didn't get it. And I'm not, look, I'll look into it. I'll look into it further. Let's go on to this, finish this class. All right, so let's see how many people are still alive or still awake. Oh, we still have 10 people. Did anyone have any questions about
Oh,
it?
I do. So like we did with the other one, you're going to define some digits of number, and then you're going to take sum equal to number divided by 10.
Yes.
And then you're going to take the
First you have
sum,
to get the, excuse me, first, no, it's not divide first. You have to get the remainder first.
the modulo. So it's sum equal modulo, or equal number modulo.
Number modulo 10.
Number modulo 10, yeah. Okay.
And then number equals number divided by 10. You have to keep doing that until the number is 0. And every time you get a digit, you add that to your sum.
And the number equal number divided by 10. And then after that, do we add?
Yeah, you have to add that you're trying to calculate the sum of the digits. So what the loop is doing is extracting a digit. So you extract the digit, add it to a sum, and then remove the digit from the number.
So then, like, what I have to, until the number is, so is that while number is not equal to 0?
Right.
Well,
yes, because after you extract all the digits from the number, there's no digits left, and that the number is then 0.
So then in my function, I have a while statement?
Yes.
Oh, okay. I didn't know you could do that.
We just did that tonight.
We did 4. Right?
Yeah, that's right.
I'm sorry. I know I'm getting frustrating. I have a very bad headache also. I'm not dumb. I swear I'm not dumb, but this is very new to me, and I feel like I feel dumb.
Oh, okay. Oh, right, well, all right. So it's, yeah, but yes, yeah, you just replaced the for loop with a while loop. Everything we did in the functions today used for loop. The while loops work the same way. I don't know if they have.
Until I do it several times, I like, it's like you're talking to a wall. Until I do it several times, like, I'm not going to understand it. Like,
That's fine. Once the class ends, nobody will know how many times you had to do it. You'll just know it. Your brain will have changed because your brain is changing as you acquire new knowledge.
Exactly. I heard that your brain grows every time you learn a language. I can feel mine. It's cramping up.
I'm forgetting languages, so I guess mine's getting smaller. I saw all the time. I sit around. What word am I supposed to use? I can't think of the word it is. I was trying to think of the difference. It's formal parameters, and the other one actual formal and actual parameters. There's another one I couldn't really think of. Oh well.
So define some digits of number colon, then it's while number is not equal to 0.
Yes.
And then I do another colon.
You have an if. No, you don't need a colon. All you're doing, you're just extracting the digits from the number. You're repeatedly the process. You're doing this over and over again. It's while number is not equal to 0. You say.
But then I have to have a colon after that, right?
Yes.
Yes.
It's while number is not equal to 0 colon. Digit equals number modulo 10. Number equals number divided by 10.
So is digit and number the same thing?
No, they're two different. The digit is you're extracting the digit from the number.
So digit equals number modulo 10, and then number equals number divided by 10.
Yes, you might have to convert that to an integer, but you'd have to convert it to an integer because Python, when you do division like that, returns a floating point number. So you'll have to convert the thing to an integer with your int thing, like we did tonight. Int, open parentheses, number divided by 10, close parentheses.
and then I return some digits.
You have to return
Number.
you have to return the sum of the, you have to return the sum, yes. Sum digits or sum of digits is the name of your function. Inside the function, you have to declare a local variable that you're going to return. And so that's the same thing we did tonight when we were calculating the, like we have right here in our, we have a function here called sum of proper divisors. And so you keep adding up your proper divisors and eventually return the sum. You're going to do the same thing.
So it's some, like my question, okay. So the return part of it corresponds with what?
Return statement in the function you're looking at right now. It's return sum. They're both going to
So
have
return. Oh, so it's not the. Oh, this is so. So it's not number. It's not some digits. It's.
You're writing another.
It's
You're
digit.
putting a different function called sum digits or sum of digits. I didn't tell you what to call it. You're going to call it something. But you're just, yeah, you got to call it something. You want to call it, don't call it Fred Flintstone. Give it a meaningful name.
So
Like
so I return, and then return has to be on the same indentation as while. Okay.
Yes.
Okay.
Because you're not going to be able to return something until the loop ends. So you can't make the return statement part of the while loop.
So now I'm getting an error. It's so like when I press the print button, when I go down and like type in print, do I type in my 13? Do I type in a number there?
You're supposed to, let's see, what you're supposed to do is the function is supposed to return the sum of the digits. So what you want to do,
hold on. The function is supposed to return the sum of the digits.
Of the digits, yes, of its parameters digits, yes.
Okay. And so, but like we said, down at the bottom is where we're going to put in the digits, the number, right?
Let's use this as a model. Sum of proper divisors.
I don't.
So you have a while loop instead of a for loop. So you calculate the sum of your digits inside the for loop or while loop. Okay. Once it's calculated, you return the sum. That's all.
Where do we put the number?
The number is the parameter.
No, not not the. Oh, okay. So I have to do like 1 to 100 or something.
No. Well, yes, you could look. You don't have to do that. What you have to do is calculate on your own two numbers whose digits are equal to one another. Then find two numbers whose digits are not equal to one another. And
huh?
You want to test it, don't you? You said, should I calculate them from 1 to 100?
I'm not even able to get it to work yet, to get it to test, because I don't know where I put the number. Can I share my screen with you?
Well, here's the thing. This is your homework assignment. You're not going to do it in class.
Okay.
It's not supposed to take 5 minutes. You're supposed to actually try it, and you're supposed to use the model, the assignment you turned in last week.
But I don't understand where I'm supposed to. So, like, we're importing a random number, right?
Yes.
Where is the number at, though? Like, so when we ran this program, did this program put a random number in?
No, not the program we wrote. Now, when I originally was going to write the program, I was going to make it generate pairs of random numbers until you got a match. But that was going to take a while, so we just finished writing the function rather than actually.
So, like, what I'm saying is, if it's not a random number, where do we input the number? Because how we were working before, we had input data.
All you have to do, you don't have to have input. All you have to do is assign a value in your program to the two numbers. Just say number equals 17, or number equals 137, number 1 equals 137, number 2 equals 16 or something, and see if their digits are equal. Think on your own. Can you think of two numbers whose digits add up to the same number? Let's think of 147. Let's see, 147, 147. So that's its digits add up to, let's see, 147. 1 plus 4 is 5 plus 7 is 12. So its digits add up to 12. So now you think of another number whose digits add up to 12. It's pretty easy. 741.
I think you're talking about a different assignment, because I'm not I'm not trying to get, I'm not doing the friendly numbers or the pals or anything like that. I'm just trying to understand the basic part of where we put the number in order to get them to add the two numbers together.
But that's where you invoke the functions. If you're seeing the screen, you can see it invoke the functions right here, under or after the function definitions.
So that was my question. We put that in under the print.
You may not have any print statements in. Look, this is one way of solving the problem. You invoke, what you're doing here is you're printing you're invoking the function, and the function is going to return the result, and you're printing the result. Now you can do the same thing, because I believe your function is. Let's see. Let's look at the problem again.
Let's say, for argument's sake, I don't understand what's on my screen, on the screen right now. I do not get that very much. It was really complicated.
Professor, is it okay if we, if some of us leave?
Oh, sure.
It's past
Yes.
9:50. Okay, thank you.
Yes. Where were we? Well, let's see where we were here. Okay, well, here's the work we had here. There's your function def is amicable. I did 4 different ways for 4 different return statements. You don't have to do that much. You're just going to write a function called, let me save this again, and I'll just reload. I don't remember if this is the 11th one or the 10th one. Fine, we'll just save it like that. Okay, let's get rid of this. Let's just get rid of all. Just get rid of all of them except one. Is proper divisors, is amicable, and I'll take that out. And so your program is going to look like this. And so I'll print is amicable 220, and I'll take is amicable 220 and 285. And that should test it, because 220 and 285, let's try is amicable.
So we have to have two functions. This is two, so it's 2 functions?
It's only one function. You're writing 2 functions, yes. You're certainly writing 2 functions.
And that's to accomplish the goal of getting the numbers to add up.
Yes, the first function adds the sum of the digits. The second number compares the sum of the digits of the first number to the sum of the digits of the second number. That's all you got to do.
You might as well told me to solve world hunger, because
But it's exactly the same thing. It's an analog of exactly what we did tonight.
But so
it's right here. See, here you calculate these. Here you calculate the sum of the proper divisors. In your case, you're going to calculate the sum of the digits. Then your PALS function will calculate the sum of the digits of the first number and the sum of the digits of the second number. And it's going to return true if the 2 sums are equal, and false if they're not equal. It's an analog of exactly the same problem we just did.
So
You don't
okay.
have to be
Well, then let's go through what we can I go through what we just did, because I'm looking at it and I have no clue what it's saying.
Okay.
I get the only part of it that I understand is the very first condition. Then after that, you lost me because you started doing it multiple ways, and I had just barely got to grasp the one way, and so like I understood the sum of proper divisors, but then you lost me.
Two numbers are amicable if the sum of the proper divisors of the first number is equal to the second number, and the sum of the proper divisors of the second number is equal to the first number.
So once we run the first function and the sum plus the possible divisor equals the sum, so what's a possible divisor again?
A possible divisor is the possible divisors range from 1 to the largest possible divisor or last possible divisor.
So possible divisor is the 1 to the last. Okay.
Mm-hmm.
And so we're not putting in numbers until you get to the very bottom.
No, there's no input yet. You're just defining the functions that you're going to use. You define your functions and then you test the functions. It's the definitions first.
What does it mean if you get like function sum digits at and then a bunch of numbers?
I don't know. You'd have to show me what you got.
Okay, I can send it in chat.
Here, let's see your screen. There's still people here, though. Okay, I think it would be better to send it in chat. Yeah, there's still some people here. Oh, this is your screen.
Yeah.
Great. All right, and everyone else can see? Okay, I'm assuming everyone else can see this. So you have def sum digits number, sum ... return sum. Def sum digits number. While number is not equal to 0, digit equals number modulo 10, number equals number. No, why would you return the digit? Isn't it supposed to be this called the sum of the digits? Aren't you trying to return the sum of the digits?
The sum of the digit. Return
Yes.
sum of the digits.
Yes, so there's no sum here.
So returns. So like what I was confused, that's where I keep getting confused on, like return. I thought it was supposed to be, so it's sum or like, so like when I looked at your examples, the return didn't have anything to do with what was up there usually.
I don't really understand. I don't know what it was. I know a number of the functions did return a sum.
So it would return some digits.
Yes, you have, but you're in your program that I'm looking at now, there is no sum. You're not calculating the sum of the digits. And you have to do that. That's why it's called sum of digits.
So then, but like, so digits, number divided by, so number divided by 10. So it would be digit plus number?
No, you're the sum of the digits. You have to have another variable called sum. You have to initialize sum to 0. You have to add each digit to the sum. Not inside the loop. You got to assign 0 to it outside the loop.
Oh, and then I take digit and add it to sum, and then number and add it to sum.
You do not add the number to the sum. It's called sum of digits. Why would you? It's not. It's got to be inside the function.
So the sum has to be inside the number, inside the function.
Yes, just like it was in the programs we did tonight.
But so then but you were saying something
I
did.
said it's not supposed to be inside the while loop. It's supposed to be inside the function, though,
Oh,
before
okay.
the while loop. Exactly. You have to look at the programs we wrote tonight and use those as models.
And so then I have to, so I extracted one number. That's digit, right?
Yes.
And then I distract, oh, then I'll have two digits. Digit
You're
one
only
and
going to
digit
extract
two.
one digit. Look, you have to look at the programs we already wrote. We already did something like this. Your homework assignment a few weeks ago was to calculate the sum of a number's digits. It's the same assignment, except for now it's in a function.
Okay, I will. Do you know what this means over here?
What is what mean? That's you're about to run your. It's just waiting for you to call. That's your output window.
But I mean, what's inside of it mean?
When you execute your function, your output will be displayed in this window.
But no, like this is what the output gave me.
Then your function is not doing any output.
Oh.
That's because you're not never. First of all, where do you find sum of digits? You have returned sum digits. Where do you assign a value to sum digits?
Where do I assign a value to some digits?
Yes, you see, you have a function
here?
called sum digit. No, that's the name. Your function is called sum digits. Where
Yeah.
does well, but why are you doing that? That's not the way the models we did tonight worked. You have a variable defined on line 13 called sum. Why are you not using that? You're not using it. Why do you put it there then?
So, okay, so it says, okay, so this isn't the right one. So you have print number here, right? And then you have up here, can you see my screen still?
Yes, I can see your screen.
Do you see my notepad?
No, I just see something that says recording.
Okay, can you see my notepad now?
Yes, I see your notepad now.
So like here it says print number. And then up here it says def is perfect number. So that's where I thought that went. I tried print numbers and I tried print digits, but neither one worked.
Yes, but you see, it's not the same thing. You're saying that you're going to print the number. You're only going to print perfect numbers. You say you're going through a bunch of numbers and you have an if statement. If the number is perfect, print it. That's what you have in your notepad for number in range 1 to 1001. If the number is perfect, print the number. But you don't have why you're just printing the number. You'll notice you're in your line 20 in your program, you just have print number. In your notepad, You'll notice that you're checking to see if the number is perfect. The purpose of that loop was to display all the perfect numbers between 1 and 1,000. So that's why you have an if statement. If is perfect number, print the number. For loop is printing all the perfect numbers.
When we did the return thing though, I remembered like return corresponded with something up here.
Yes, it corresponded with the calculation, the sum. Let's see, it says if sum is equal to number, you want to know if something's a perfect number. So you calculate the sum of the digits. If the sum of the digits equals the number, return true, else return false. So the whole point of that loop, first of all, the whole point of the loop is to calculate the sum of the number's digits. Once you get the sum of the number's digits, compare it to the number.
So when we return, what we're returning is what? Like we're returning the function? Like that's...
You're never going to return a function. You can return a function, but in this class, you're never returning function. You're returning numbers. No functions, numbers. That's all we've ever written is numbers. Functions that return numbers. That's all we did tonight was functions that return numbers. Now, we're looking at your function sum digits. Now, you have in here return sum, but that means your function is always going to return 0 because you never change the value of sum.
But so like what if I put in here, I would write in here sum equals digit plus digit?
I'm not going to write the program for you. You
No,
figure it out.
I'm not asking you to write it for me.
Yeah, well, you are, because there's only one. There's only that you're supposed to add up the sum of the digits.
So
and
I
you're
have to
asking
make
me.
some, so what I have to do is I have to make some.
Listen, what you have to do is do what you think you got to do, and then test the program.
Okay.
That's what you have to do.
Sure. Thanks.
The name of the function is sum of digits. You have to have something that's adding up the digits. Now go look at
So I have to get digit 1 and digit 2, and
there
then
is
add
no
those.
digit 1 and digit 2. There's only digit. What
Do
you're
I
doing
make
is you're
a digit
extracting. Look, you're extracting the digit in the loop.
Yeah.
Each time you get a digit, you add it to the sum. You don't. There's only the digit. Only the last digit that you extracted from the number.
So my first digit is going to be digit, and my second digit is going to be number.
No, your first digit is always, look, what if the number is 136? The first digit is 1, the second digit is 3, and the third digit is 6.
Yes. And then what I'm going to do is I'm going to divide that, or I'm going to modulo that by 10, and so I'll get 113. I'll get 6, right? Remainder 6. No. Can we do a simpler number?
Look,
So
let's
if I
say the
did,
number is 13. All right, so if number is 13, digit is equal to 3. Then number divided by 10 is equal to 1. Then,
and then number plus digit is equal to 4.
But you're not adding number to digit. You don't. What is the variable sum there for? You're supposed to use it to calculate the sum of the digits. You're supposed to add each digit to sum.
So I'm supposed to add. So, so I add digit and number to sum.
No, you do not add number to sum. It's a sum of the digits, not the sum of the number. It's just the sum of the digits.
But when I'm so like I have to extract the first one using modulo, and then don't I divide that by 10?
You're not dividing the digit by 10, you're dividing the number by 10.
Dividing the number by 10. Dividing the original number by 10.
Yes, the number keeps getting smaller every time you divide it by 10. That's why it says number equals number divided by 10. See, the first thing you do, you get the digit. Then the first thing, digit equals number modulo 10 gets you the digit. Then number equals number divided by 10, number divided by 10 removes the digit from the number.
That's why, so like that's where my logic is coming from. So I remove one digit with that first line, right? With line 15.
Yes. Mm-hmm.
And then I remove the next digit with line 16?
No, you always remove the digit with line 16. I'm sorry, 15 does not remove a digit from the number. It simply finds out what the digit is. See, digit equals number modulo 10 does not change number. The only way you can change number is for number to appear on the left-hand side of an assignment statement.
Okay, so then we get the digit by 15, and we get the new number by 16.
Yes, this was a homework assignment or classwork assignment a week ago. And if I recall, you asked me similar questions about this. I think an example was 17. And I said, so let's see. I remember that. There was digit 1 and digit 2. And you thought that you had to declare a variable for each digit. You don't. You're removing the digits in a loop. Every time you go through the loop, number equals number divided by 10 removes the rightmost digit. And you start off removing a new digit when you go through the loop again. The first statement of the loop on line 15 gets you the rightmost digit. It doesn't remove it, it just assigns a value. It assigns the rightmost digit of number to digit. Then when you remove the rightmost digit and then the next statement on line 16 removes the rightmost digit. And when you go through the loop again, you have a new rightmost digit. Because the last time you went through the loop, you removed the rightmost digit.
Okay.
Every time you go through the loop, you remove the rightmost digit.
So say we have 13,
Yes.
and 13 modulo 10 is
3.
3. And then so we have so I have 3. And
Yes.
then it takes, and so is 3 the number now? No.
How would it be the number? You have to ask yourself these questions. How could 3 be the number?
So then number is still 13.
When you execute line 15, yes.
And so when I execute line 16, 10, so number is divided by 10. So 13 divided by 10 is 3.
No, it's not.
It's.
Remember we discussed in class that when you divide, okay, look. What is 13 divided, when you 13 divided by 10 is not 3?
1 point something?
Yeah, that's because you forgot. Yeah, but you don't want 1 point something. You have to convert the thing to an integer.
And so when I convert that to an integer, it chops off the point something.
Yes.
And then so I had 3 from the first one and 1 from on the second line. And then I want to add the first part to the second part. Right?
Again, you have to look at the stuff we did tonight. You have to use the variable sum. But yes, you're going to add the digits together, but you cannot calculate all the digits at one time and add them together. You have to add them as you extract them from the number. As you extract each digit from the number, you have to add that digit to sum. You cannot wait until you have all the digits and then add them together. You have to add them one at a time, exactly as we did tonight when we added up the sum of the divisors. The sum of the proper
added
divisors.
up the sum of the divisors. When we added up the sum of the divisors.
It's the same thing, exactly the same thing. It's all the programs we did. It's the program we did tonight. The program I was just looking at, the one that you said I did the if statements too many ways. Just look at the first way, the one that you understood, and see how that one adds up all the divisors.
Do you have it up still, or do you have? I'm sorry.
Let's see here.
I'm gonna let you go because I feel like I'm frustrating you. I'm not understanding it any better, and I can look at the notes, but they might as well be in Chinese.
That's looking enough. Can you see my screen now?
Actual language.
Well, I can't. Where are the rest of these things? All right, this is this one. Look, see, I can't explain it any more than I have. You see, what you're doing is you're adding up. If you're looking at my screen now, I'm assuming you can see it. Okay. What I'm doing is as I go through my for loop, I add to sum each number that divides that can divide number. I don't add them all at once. I add them as I get them. As I come to a number, if possible divisor divides number, then I add it to the sum. But look how I do that. Sum equals sum plus possible divisor. Yours is a perfect analogy of this. What you're trying to do is very similar to this. You're going through and you're getting a digit, and you're adding the digit to the sum, exactly in the way it's being done here, except for instead of possible divisor, you have digit. You'll notice that I don't look at all the divisors. I only look at one possible divisor at a time. That's all I do, one at a time. That's all you have to do, is look at each digit one at a time. And as you get the digit, add it to the sum, just the way I'm doing here. Sum equals sum plus digit.
So, so sum is equal to sum plus digit, and then I return the sum.
Once the loop, I don't remember what the problem. Yes, I believe you're supposed to return the sum. Because the sum is a function is called sum of the digits, or sum of digits, or sum digits. That would suggest that means you return the sum, yes.
And so like my sum is equal to sum plus digit, the digit that I got in line 15, and the sum that I set out beforehand.
Yes, we have to initialize the sum to 0, just as it's done right here. Where on line 2 it says sum equal to 0.
And then I print the sum.
You don't have to print anything in the function. You're talking about in the function?
No, I'm talking about outside of the function, because that's the only.
But you see, you have to use the function again. You have to calculate the sum of both digits. It's not asking you to print anything until the function doesn't have to print anything. You'll notice that these functions don't print anything. You see, I have sum of proper divisors, and then I have is amicable. There's no print statements in here. The functions
I
don't
understand
print.
that, but like I'm talking at their. Oh.
Yes, you can print them after they end.
And so I need to have two. I need to have two of these. Like I need to have digit. I need to take that statement. I need to make that loop through again.
You only have one loop. The loop repeats itself for as many digits you have in the number. If the number is equal to 7,942, then it's going to repeat 4 times. If the number is equal to 7, it's going to repeat 1 time.
Do I have to let number equal something like to run it? Because I can't, you know what I mean? Like
when you invoke the function is when you give a value to number. Just as we're doing right here, where it says print amicable 220, 284. That's where you give a value to the 2 parameters. See, is amicable number 1, number 2. You give a value to number 1 and number 2 when you invoke the function. 220 and 284 is invoking the function. When you invoke the function, you copy the value of the first parameter, the first argument to the first parameter. You copy the value of the second argument to the second parameter, and then you do all this stuff inside the function itself. So you do not assign a value to number 1 and number 2 inside the function. Those are parameters. You assign a value when you invoke the function, you send and you copy the function's arguments to the function's parameters. So nowhere inside these functions do you see me or do you see the program assign values to number. You don't see it assign a value to number here. You don't see it assign a value to number 1 or number 2 here. So you never assign value. Well, in these programs, it's not necessary to assign values to numbers, number 1 and number 2. They get their values when you invoke the functions with the parameters. You're going to do the same thing. Your function will have 2 parameters. And when you invoke the function, the arguments, when you invoke the function, the arguments will be copied to the parameters.
And then so we're not getting a random number and it's not user input this time. We're just doing it. We're writing it.
User input here either. See, there's no user input.
No, okay, I get that. I see that. My question, it's a question. I'm saying there is no user input.
Why not? Why is there no user input?
I don't know, because you can tell us the user input.
All you're trying to do is test the 2 functions. The program
we're
asks you
just testing a function.
test the function. I'm sorry?
So we're writing a function and then testing if it works without using input.
Well, yes, it's possible to do without input. Yes, you could just assign constant values the way I've done right here.
Okay.
There's no input here. You can do it with input. You can do it with random numbers. There's several ways to test the function.
And now, when you say test the function, like, does that mean, so when you say test the function, does that mean we put several numbers in and see if it works?
Yes, you see if you get the right answers.
And then like when we send it to you, do we include several numbers or do we leave that part blank?
Well, what you have to do is just send me everything you wrote. Everything is inside of one file. So it's not possible for you to send me the function separately without the statements you use to test the function. You can't separate them.
But I mean, like, so should we test it with one number or 5 numbers? And then like, if I test it with multiple numbers, my question is do I like put them all? So if I test it with 12, 13, and 9, do I leave those in there and then send it to you that way?
Why not?
And can it can run multiple, it can run that thing for different numbers, correct?
Yes, you have to write it that way. That's why that you remember how you write it. You copy the value of the arguments to the parameters. Therefore, the function can work on different values of its parameters or the different arguments.
Different arguments.
Just like the thing you're looking at. Well, that has a say. Well, the first of the one you're looking on the screen, the first parameter is 220, the second parameter is 284. On the second time, the first parameter is 220, the second parameter is for argument rather is 285. Now you can write in more stuff. Let's go on now. You can write in more things. You can write print is amicable.
So it's not within the
and
scope
285.
So it's not capable, it's not able to do them as like an array or a series, right? You can't just do commas between several numbers you want to do.
You actually can, but we haven't gotten to that yet. Those are called lists. Yes, you can make a list of it, or you can use a for loop and give it a bunch of numbers. You can do 2 nested for loops and give it numbers. You can have very, very elaborate tests, but you don't have to do that many tests to see if the thing is working.
Okay. Okay, well, I do understand better now, and I do appreciate it, and I thank you. And I apologize.
Well, no, the programs are supposed to be analogs. This program you're looking at on the screen was supposed to help you write the programs that you're trying to do right now. Also, your previous homework assignment was the same thing that you're doing now, except for you're putting in a loop, but it's the same statements. It's exactly the same thing, except for it's not in a function.
And our program is a lot simpler.
I'm sorry?
And our program is much simpler.
It's not that it's much simpler. It's because you put in a function, you can reuse the thing. You can reuse the code much more easily. Without the function, you have to write the same statements over and over again. With a function, you can simply invoke the function several times.
Without the function, you can write the statement several times.
You have to, not you can, you have to. If you want to carry out these actions several times, then you have to do the statement several times.
Oh, so what this function does is allow us to do the function anytime within our code just by typing in print and then that function and then of the number.
Yeah, something like that.
So it saves us like the purpose of the function over doing it the way we were doing it before is what?
Yeah, this is homework 6, problem 1. So you don't have to, you can reuse the code. You don't have to keep writing the statements over and over again. It says, write a program that reads a positive integer from the user, computes the sum of the positive integer digits, and displays the positive integer in the sum of the digits. This is homework 6, problem 1, which I believe you did.
So before we would have had to we'd have had to write the code again if we wanted a new answer, or we'd have to run the program again with new number to get another answer.
Well, you still have to run the program with new numbers. You just don't have to repeat the code. The code is encapsulated in the function.
But like, so to get a new answer in the other program, we have to run the code again.
You had to write the statements again, yes.
But in this, all we have to do is type in a new. Well, I guess we have to run the code again.
You have to invoke the functions twice. You don't have to write the statements twice. You just have to write the functions twice. You have to invoke the functions twice. You don't have to write the statements in the function twice.
We don't have to write the statements in the function twice.
You see,
so for every new time we want to run it on a new set of on a new number, we don't have to. We can run it on any amount of numbers without having to write the code again.
Yes, you just have to invoke the function, call the function.
Okay.
Don't you remember doing homework?
So if we like put a bunch of different functions into one code, and then we were go to another place in that code and then like print the results of the different functions, would that be like what you would use on on like a more complicated app?
Yes, you do. You don't. Yes, you want to reuse the code you've already written. You also want to parameterize your code so it doesn't just work on one number. It works on any number because you can give it different parameters. This is what we've been doing. Well, yes, you give it different parameters. You give different values to the parameters, and you can simply calculate. You can perform those calculations on different numbers. It's the analogy that I gave you about the square root function. The square root function doesn't just calculate the square root of 2. You just give it different parameters, a different value, and it'll calculate the square root for different numbers. The square root function will give you the square root for any positive number. Just like your function will give you the sum of the digits of any positive number.
So basically, this is like programming a button into a calculator.
Yes.
Okay. Okay. Thank you so much. I really appreciate your help. I'm sorry for.
Why don't you look at homework 6, problem 1? This is what you're generalizing. You're sticking your solution for homework 6, problem 1 into a function with a parameter. Let's see. Did you do this assignment? Let's see.
I did.
Good. Then it's the same thing. It's the same idea. I mean, it's actually the same. Okay, and I gave, let's see. So this is it. And there you have it. Why can't you put these statements in a function?
I was getting thrown off by the return part.
But the return, well, okay. Functions have to have a return statement. Otherwise, they can't get the results of their calculations back to the users of the function's users.
I understood that there had to be a return. I just didn't know what word to put next to it. So in this,
trying to calculate. Okay. All right. Well, there. Now you got it. Now you got it. There you got it. So, yes.
Because I was thinking you were supposed to return the number, and then I thought, no, you're supposed to return the digit. Then I thought, no, you're supposed to return the sum of the digits. Then I finally understood you're supposed to return just the sum.
Yeah. Well, okay, great.
I shuffled through every single possibility that it could have been.
Well, that's good. That works. Okie dokie. Then I will call it a night.
You have a great one. I appreciate your help. Sorry.
Let me see. Now I can stop recording. Stop recording. All right. I remember. I usually don't remember to record stuff. Well, let me see. I hope amidst the other 3 people more here, does any one of you, we're going to stop now. Do any of you have any questions? Good. Okay. So everybody, we're going to stop recording now. If you have a question, please ask. I might bite, but I can't do it because you're somewhere else. Isn't that what some of you, I don't bite? I do bite, but I can't. So, so good. So we're done. Okay. So I'm gonna stop recording and I'm going to end this session.
Okay. I will see you later on this week. Thank you so much.
Again, All right, so let's get out of here. I'm going to click end meeting, and that'll be it.
Are you still gonna? One more question.
Yeah, no.
Are you still gonna have office hours on Sunday?
Yes, sure. Yes.
I will see you Sunday.
Yeah, I'm going to try. Okay, went kind of messy last Sunday. I'll try to do a better job this Sunday. I'll try to do a better job. We'll see how it goes.
You did. You did. I think you did a pretty good job.
No, I mean, no. Well, we didn't because anyway. I'm going to look into what you suggested.
Okay.
So I'm ending the session, and this is it. Good night.
Bye bye.